All right, let's start this. Got a lot of material to go through today. All right, my name is Ed Keenan. Can you guys hear me with this mask on?
Yes, sir.
All right, I'm thumbs down on the mask. I feel like I'm choking.
I agree.
Hopefully one more week and throw away those things. All right, this is Optimize C++. This is going to be the best class ever.
Yeah.
Say that. The weird thing here is what I don't think people get, and also everybody who's online, I don't have a video of you. I don't have two screens. I just have one screen. So please interrupt, stop the thing, just ask questions out loud, and we can hear you. So let's test that. Can anybody hear me online?
Yes, I can hear you.
Okay, great. Okay, so it's working. All right. So one of the things that I think is really interesting is we want to be software developers when we grow up, right? Grow up. It's fun. It's fun. This is the most exciting, interesting, challenging, just a crazy field to be in. And it's so much better than any of those other lame jobs, right? If you think about it, how can you get a field that every day you question your existence, right? You're like, am I good enough? Can I code? Are they going to find out that I've really been faking my whole life, right? And then you're like, okay, well, wait a minute. I just want to have a bad couple of years after I graduate, learn the ropes. My dad's seasoned, my mom's seasoned in their jobs. I will be seasoned in 5 years. No way in hell, right? You are in the only field that the longer you're in it, the more obsolete you become. 10 years just means if you haven't stepped up on it, you are now worse than the new grads. So this is an awesome field, but we have to just acknowledge that it's challenging, right? And I have a ton of experience, and I'm going to share all kind of weird anecdotes and stories and everything else with you guys. But I just want you to understand this should be fun. If it's not fun, change careers. This is really a weird field. My mom still doesn't know what I do, right? I'm in my 50s and she has no clue what I do. She's like physics or nuclear or something or another. She has no clue. You work day and night on a problem and you sped up the cache, right? Like, holy shit, this thing is 10 times faster. And you go home and tell your friends or your partner, and you're like, I made my cache 10 times faster. And they're like, yeah, what is a cache? Why do I care? So it's very much an internal field, right? And it's very contentious. What if I can go in your brain and see how you think?
I don't know if you like.
Would it be scary, right? It'd be scary, or you're like, oh my God, this guy's a future serial killer, and you look at this stuff but we write code. I see how you think. You see how I think. How I thought last week is different than how I think today. And because you can see my thought process, I'm very, very open to criticism, right? I'm open to critique. I'm insecure. This is normal, right? And I don't think a lot of times the classes you're taking, I don't think they can tell you like the secrets of how this shit really works. You're always scared. You're always saying, I'm a phony. They're going to discover me today, right? Can I do the assignment? I don't know, but I'm supposed to be able to do the assignment, right? This is normal, right? Embrace it. Yearn for it. And over time, you learn to love this stuff because you love that you can go into an environment that you have no clue what you're going to do, and you have somehow dig your way out of it. And that's an exciting part of this field. And I don't understand why people aren't excited about software development. And I think it's the way it's taught. I also think I'm a little bit unique. I have 20 years experience in industry, making video games, anybody watch the high definition TV in the last 10 years, 20 years? I did it.
Yeah.
Every day is a joy when you work on something you love, right? So what I'm going to hopefully do is inspire you guys to like what you're doing. Be challenge each other. If you only code enough to do the material in the classwork, you are not coding enough. If you don't have side projects and games or things you want to try to improve on, or just take the teacher and like, oh, I can do better than that teacher. The teacher doesn't know what they're doing. That's the kind of attitude to get you to drill and practice more, right? So let's say you're going to be a world-class tennis player. You probably are training a lot of hours every day. You're training in the morning, you're training in the evening, you're doing competitions. Well, we want to be professional programmers. Why aren't we training? The only day you should not have your computer open and coding is the day you're so sick that you're almost hospitalized. If you're not that sick, you should be still have a terminal. I've actually coded in a hospital room with a laptop on my chest, right? It has to become a part of you. It has to be your favorite friend, the compiler. And the good thing is, this right here, at least this class, other classes I teach later, it's not true. But this class is awesome because it's a program. It does exactly what you tell it to do. The problem is we don't know what we're telling it to do. Does it change? Will I run it 100 times? It will do exactly the same thing 100 times. There's other problems in other fields where it's probabilistic. The energy might be there. You play pinball, right? Everybody goes, oh my God, like, why do you like pinball? It's like everybody who does video games loves pinball. It's really interesting. Like, wait a minute, we're going analog and that's digital, right? Well, in computers, there's patterns. You have to program the AI. Once you understand the AI, you know how to go around the AI. But today it's humid out. The wood is a little bit more warped. The ball bounces around. The solenoids it's a little dry out. There's a little more static electricity. The solenoids fire off differently. There's all this different things. You have a little bit of English, wear out. All these different things happen on a mechanical thing that adds surprise. Programming, there's no surprise. It does exactly what it's doing. From our perspective, that's great. That means if we make a mistake, we can recode it or step through it, and like it'll make a mistake again, right? So then you're like, well, what about networking? Well, we can record packets and play the packets back. Everything is deterministic when you're on one computer. When you get 2, 3, 4, then you don't know what the other guy's doing, and that's the challenging part. So right now we're in the kind of the cool phase. We're in double great phase because we're developing by ourselves. When you work on a team, you're coding and then your coworker just screws it all up. Or you go home at 5 o'clock, they stay till 7, they totally screw up the whole build. You come in the morning, nothing works, and then you're yelled at. You're alone. So whatever you code is your problem. Who do you blame? Yourself. If you stop and it's half working, like I'm gonna go eat. Close the computer, come back, it's right where it was. So we're in a great environment. And so there's really no excuse like, oh, the dog ate my thing or whatever, right? But we can exploit that. And so we'll kind of go through this stuff and how to exploit this material. So let me kind of give you the background of this class. So way back in the day, I was in the industry and I'm like going, you know what? I want to teach a class at the university because I'm sick of programmers not knowing how to do certain things, right? And so I came here and like, I want to teach this really cool computer science course. And the computer science department here goes, you're a game programmer. I'm like, yeah. Let's put it in perspective. I'm a game programmer who's been programming multiple processors. We make our own ASICs. We do the latest and greatest coding. Our coding is superior to everybody else's coding. Yeah, but you're a game programmer. So they wouldn't let me bring it in a class to computer science because I was a game programmer. So my pitch was, well, let's call it a game class. So here's the pitch. So back in 2009, in the beginning, there was monkeys. Soon they begin to learn. If you recognize the symbolism, this is 2001. Then they started to use tools. And eventually typewriters. And since they could type, well, then they could program. Now, a couple of you guys are right off the bat like, you said monkeys, that's an ape. The difference is one has tail, another one doesn't have the tail. I get it, but I couldn't find a monkey coding. So this is the best picture I could find. So the coder monkey was born. Not bad because, you know, coder monkeys get money. But imagine a ninja, right? Who just understands this really unorthodox kind of style and techniques of warfare, right? But what are some of the roles of a ninja? Sabotage. So they sit there and try to weaken the enemy. Espionage, they try to gain information. Scouting, assassination, and warfare, right? The enemy is performance and resource usage. And so what we're going to do is we're going to just sit there and gather information by doing scouting. We're going to disrupt behavior by changing the code and sabotaging it. We're going to try to understand as much information and try to understand what other people are doing, what hardware manufacturers are doing, and how do we exploit that. We're going to attack high performance spikes, and then we're going to refactor and attack again, refactor and attack again, right? So the Code Ninja is born. And so what we're going to do, and this is, remember, this is 2009, so this is kind of dated, but it's kind of holds, was to work on the extended matrix instruction set, dynamic memory usage, file IO, profiling, metrics, and refactor and real system, right? So this is the original pitch way back in the day. And so I got the okay to do this. At the same time, my company folded. So I started my own company. Well, I got a job in Reykjavik, head of engineering and for CCP Games in Iceland. Then there was a volcano that went off in Reykjavik, so I couldn't go there to move. Then there was a internal civil war, so I didn't go there. So I started a firm and worked on high frequency training. And then Paul goes, "Hey, you want to teach that class?" So I taught the class and now I'm here. And so this is kind of how I got to this place. So here's the class, right? And it's not too far off the original pitch and the original material. All right, so some kind of like instrumental business stuff here, and then we get into the fun stuff here. Email, there's my email. Don't forget the number 2. Don't ask me why there's number 2. A lot of people don't have a number 2, but I have a number 2. There is no first Keenan. We have an office, but it's in, my phone, I never answer. I only do emails, right? So that's that. All right. So why did you take this class? I'm curious, why did people take this class? And if it's required, I get that. I want other reasons besides required.
I want to actually start my concentration, and this is kind of the gateway to get there.
Yeah, this is the footpath in there. Anybody a Java programmer? Python, C#?
Java, Python, what I started with.
Yeah, so if you understand C++, you know Java. It's C++, you can put a couple training wheels on it, boom, you got Java, right?
Mhm.
And if you get down to it, what is C#? Well, original C# was called J++, made by Microsoft. And I actually watched the lawsuit that happened in DC. And they go, no, infringing on Java. So they literally at the trial changed it, and they go C, and they look around like, oh, # sharp. So Java and C# are equals. And then C#, Microsoft started to extend and promote some things in C# that are slightly different, but they're essentially the same. So if you understand C++, you will be a better software developer in Java or C#, just by definition. And when I mean better, I mean your code will run faster, right? Other reasons why people take the class.
I have more. I
Yeah,
can say.
go ahead.
I mean, understanding that like Python is like, here's what a variable is, here's what a function is. It's like it starts there, and then you work into like Java to start using that. Once you get to here, it's like, here's how you can use everything you know to every other language you could get to. It's like, that's how I've been looking at these classes now. It's like, once you know how to do one thing, you can apply some of the same aspects to a new one in a different syntax.
All right, yeah, so what you'll find is that Python, I'll pick on Python now. Python is doing pretty good. There's a lot of attachment right now. People can start using it, but Python calls libraries. And if it didn't call libraries, Python would be dead in the water. We would never be saying that word again.
Right.
Those libraries do all the heavy calculation, heavy lifting. Those are in C++, right? To give you an idea, if you did matrix times matrix multiplication in Python. So pretend that's unit 1, it takes 1 unit. And then we do it in C++ SIMD, right? How many times faster is C++ SIMD?
That's a lot.
I don't know, 64,000 times faster.
That's a lot.
Yeah, and I'll show you the literature on that later because everybody's like, oh, Ed's making up numbers. 64,000 times faster. That's amazing, right? Just think about that. All right, so when you know C++, you can do a lot more things. Even if you never use C++ after this class, your coding will change. You will see problems in ways to approach this. True or false? Java and C#, do they use pointers or not use pointers? They use pointers all the time. They just call them references because they figured the population would be scared of the word pointer, right? So in C++, we just acknowledge it's a pointer. And we do this little arrow thing. In Java, they say, it's a reference, we'll just dot. Same code. When you look at the underneath, it's the same code. So you've been using pointers all along. So you shouldn't be scared of them, and we'll get through there and kind of square you up on those issues, right? Anybody worried or scared about this class?
I will honestly say yes, but I am also confused on the fact of other people saying how bad it was, but then going through what we've been going through before.
Yeah, you gotta always listen to anybody who says it's bad, listen to who's speaking.
That's what I started keying in on. There's always the students that don't want to even apply themselves or are doing less than the bare minimum.
Or
It's like-
historically been lazy,
That, yes.
and now they're like, oh, because I assume you understand the material. So this class is not hard. It gets a bad rep because of the slackers, complaining about it.
They're the only ones that will put some kind of review
Right.
somewhere.
This is the first class in like a 9-course sequence that I teach. That's to show you that this is the baby class.
Yeah.
And now if you ask the people 1 year, 2 years after, what do you think of Optimize? They're like, I don't know why I was so worked up. I don't know why I was stressed out. I don't know why it was hard. If I had to do it again, it'd be 3 hours a week. The problem here is this class is hard, not because the class is hard. It's because you're gonna pay your dues for the stuff that happened beforehand. So did you take data structures before? Well, then you should know how to use it. Sadly, sometimes the data structure classes aren't taught in the best way. If you had assignments where it's fill in the blank, you didn't learn it, right? If you think you understand something, teach your friend. Let's go with this, go to high school and teach somebody calculus or algebra, right? You're like, oh, I know this. And then you start to like, I got an A, but who cares what grade you got? Can you show and demonstrate it? If you can't show and demonstrate it, you don't know the material. And I think that's what's happening here, is that this class here, we need enough of programming to show you the cool stuff. That stuff is from 6 previous classes. And so some students have to kind of go back and fix up their previous material so they can be successful here. So the best analogy is if you take in math courses, so you take Calculus 3. Calculus 3 is based off of Calculus 2. If your Calculus 2 is crappy, you could get a B. You had that easy teacher that gave you an A. You had a hard teacher who gave you a C. But if you don't know that material, you're gonna have troubles in Calc 3. Is it Calc 3 is a hard class? No, it's because you don't know Calc 2. And I think that's what's happening right now. People's data structures and OO development and inheritance and methods and just general programming and debugging are somewhat weak. Don't worry, we'll square it up.
Yeah, I mean, I empathize strongly with your data structures class is very fill in the blank. I think my concern is like, is one of the things I would like to know is like, is there a way for me to like assess myself or like a litmus test I can use of like, I am adequately prepared for this? Because
Well, you'll get the first assignment. It's actually in your hands right now. So it's up there. It's this data, we'll go through it and we'll start coding together. So I do a lot of interactive coding. This is not, let's put it this way. If you're willing to put in the effort, I will get you through it. If you stop going to school, stop doing the homework, stop opening that compiler every day, then, you know, you kind of reap what you sow, right? But I can get you there. We have extra, I have no problem doing extra classes, extra videos, any of that stuff. I'll get you there, square you around. But you have to put in the effort. For some people, this is an easy course because they're prepared or they come from industry. For other students, it's like, oh my goodness, this is the reality course, right? It's doable. There's nothing hard here. And like I said, if you talk to the students who've taken this 2-3 years later or a year later, they're like, I don't know what the mojo is about this, right? It's pretty straightforward, right? All right, so this is college, university, right? And I'm tired of, you guys have to get your money worth. I mean, to me, it's dollars and cents, right? So I'm first generation, my parents didn't go to school, blah, blah, blah. So I went through all this stuff myself. And when I was in engineering school, every class kicked my butt. Every class I questioned, am I gonna finish my degree? Every class I worked all semester insanely hard, full-time on academics. I don't know why that shouldn't change. This is not high school. We're not gonna spoon feed it anymore, right? So if you take a class that reads out of a book, why did you pay the money for the class by the book? The teacher is here to guide you through material and also augment material that's not there, right? So this class is broken into 2 halves. Every week is the material that I cover. Every week there's material that you can take 2 seconds and Google or read the book, right? I will help you with that material if you get into trouble, but I want you to do some legwork in prep. You spend 10 hours on this assignment, then you come back with a really smart question. Like, okay, here it is. Oh, like now I get it. I can spend the whole class talking about how to do this. And now you're still no further ahead in your journey. So to me, we have to kind of put back the independent researching and development that you should have all along, that I think the schools have gotten a little soft on you. And I apologize for that because I'm part of that community. I'm always against it, but I'm part of it, right? So don't worry, we'll get you through it. You don't need any C++ knowledge in this class. So if you come in here with 0, fantastic. Come here with experience, great, I'll tweak it. But you really already know everything about C++. You just don't know it yet, Dorothy, right? Wizard of Oz. You always could have gone home. You just didn't know you could, right? You have the power. Now, by the way, Wizard of Oz was written in Chicago. Just got a side note. All right, so why do I say you know C++? Everybody knows Java or C#. So what do you get from there? Inheritance, methods, objects, right? All right, we've taken systems. We understand what a stack is, a heap is. We've been introduced to pointers. You're done. That's C++ right there. So we're just going to clean it up and make sure you understand it, right? There's a lot of things that you're doing that you didn't know was happening. So the real surprise is we don't understand the code we write. So how many people have called the function square root in Java? Right? Did you look it up? That's my point. It's just so simple. We all use square root. Did you take the 2 seconds and Google, what does the square root do? And what parameters and what's precision and how many cycles and how does it perform. So the surprise thing here is in C++ or in C, if you type in square root, you pass in a variable float, it goes, oh, I take a double. So it converts it to a double. Then it does double square root, which is super slow. Shake and bake, answer, it's double, convert it back to a float. Holy crap, you just did it 4 times slower than you needed to. If you would have Googled it, you say, use square root f, and then boom, it's 4 times faster. That's what I'm getting at. We don't understand the code we're calling. We don't understand any of this stuff. So I'm going to kind of force you to start looking at stuff and then slow you down a little bit. But the good news is you at first slow down, you're looking at everything. And over time, you get confidence, you don't look at that stuff up as much, right? If you think you understand your code and you think you understand a concept, here's my thought process you should do. I'm willing to take my phone, put it on the table, and if I'm wrong, you can take my phone. If you can't bet your phone, I used to say car keys, but now phones I think are more important to people. You don't know it. And that's a really good barometer. If you were not willing to sit there and bet your $1,000 phone or $500 phone, you do not know the material. Think about that for a second. All right. Any questions for me? Anything, it could be anything in the world. Nothing?
I do have a question, but I think it might be for a little bit later, just for like the setup of stuff. So I was running.
Okay, we're gonna go through that.
Yeah, so it'd be for later.
All right, so this is an applied course, and this is my philosophy that kind of changes the way you look at things. You're going to code and experiment. If in this class, you can get every single assignment correct and still fail the class. It has to be done fast. It has to be done efficiently. We're not in this mode like, hey, it works, pat yourself on the back. Those days are gone. We've got to be in the professional mode here. Of course it will work. Of course there'll be no errors. Now, can I write it faster? Can I write it in a more efficient manner, right? So to do that, you have to experiment. You try some things out like, oh, that didn't go right. Do this. Everything you do in this class, you have instant feedback. I give you unit tests. You see your score. You know if you're doing it right or wrong. I wrote a really elaborate memory system tracker. So if you're leaking memory, it yells at you and said, hey, programmer, on this file, this line, you leaked this new. Call delete somewhere. So I wrote all that stuff to make it in a better environment for you, right? Work individually. I don't believe in groups. You'll have groups in the industry, right? The problem with groups, when you're in groups of 3, 4 people, I do this problem, I do this problem, this problem, and then there's slackers. Or because you always work on this type of problem, you didn't learn the other stuff, not because you couldn't, but your role was to learn this job. So working individual, I can quickly see where your weak points are. I can help you in there, right? You're gonna take code that you used to do and fix it. Something you did before, fix it again. That's how you iterate and get better on it, right? Competition. Nothing's better than bragging, right? Bragging rights. Oh, you got there first. Okay, now I have to get there. So we communicate, we kind of talk stuff, and we kind of help each other, push each other to the next level, right? So we're going to be talking a lot, interacting, but we're going to program a lot, right? So we're going to have code reviews. Code reviews are awesome because this is a way to publicly go through somebody's thought process, right? Oh, that sounds so much fun, right? I get to be embarrassed in front of the whole team, right? But we can do it in a constructive, creative way to get through this stuff. There's 1,000 lessons that I'm trying to pour in your brains. And some lessons are like, it works, but why did you, like, I'll give you an example, right? F, X, 3, right? Is that correct? If X equals 3, Y equals 4, is that correct?
You know?
Correct in what sense? What are we trying to?
Compiles,
Yeah, it compiles.
compiles, right,
Yeah.
right? But I would suggest always put in parentheses, just always, just do that. And if you forgot one of these, it's an assignment. So what you should do is put. Now, if you forget one, it goes compiler. Your code was correct all along. I'm going to give you guidance on how to make it more robust, make sure you don't fall into the same mistakes. So little tweaks like that. All right, we'll do demonstrations, challenge. Say a big line that says erase. All right, we're going to make a lot of mistakes. I'm going to code and show you some mistakes on purpose. Walk right into walls, and you can kind of see how I dig out of it. Right. So prereqs are data structures in some language that's OO oriented. Computer systems. If you have computer systems 2, great. 1 and 2 doesn't matter. I'm going to show you how to all the computer system that we need correctly. I used to do hardware, so I understand how it really works. All right, so syllabus, right? Look at that syllabus. All right, this is a combined class, meaning there's undergrads and grads in it. So for technical reasons, we have to differentiate the two groups. I'm 100% opposed to this because you guys all have the same prereqs, data structures and systems, right? So why do I have to treat the grad students differently than the undergrads? You guys both have the same background. But we have to kind of change 10% to kind of make it all happy. So, all right, so here's all the info, blah, blah, blah. Here's the learning goals. What we're going to do is analyze software, identify performance problems, caching algorithms, compilers and unintended things, fix those. Reduce some spikes, use an analyzer. We're going to do all this kind of cool stuff. But here's the stuff that people are worried about. The homework. The homework works like this. There's PAs, which is every week, programming assignments, PA. And that's the meat of the class. I'm gonna teach you techniques. This is all gonna be related towards optimization in some fashion or something about the language. Then we're gonna have every week a 1% assignment. That's your basics, which is like, how to use strings? Google how to use strings. All right, do the assignment, you learn strings, and if you have questions, ask and we can help on that. So that's that 2 voices, right? I'm saying like the C++ basics is kind of, on your own. So this is all, lookup, / book. And then the other stuff is all the stuff that I do, right? I'm not here to hurt your degree, hurt your grades or anything like that. And I don't know how to erase anything. Oh, that turned out good. Oh, I know why I'm on a Word doc. All right. So every single assignment you turn in, you can redo it again. Just the maximum the second time is 70%. This is just for the PAs, which is the heavy point of this. You're 55% versus 10%. So the 55% you can redo any assignment. If it takes you 3 weeks to redo it, I don't care. And I will regrade that and give you a maximum up to 70%. So this way, if you kind of screw up a class or a week and you're like, I'm gonna belly up on this one, don't worry, just redo it and you can get a 70% then. For the first assignment, and only the first assignment, I got a deal for you guys. If you see in a tutor from CDM, for those who are online, international, it doesn't matter. You can set up an appointment with the tutor on CDM. I'll send you a link. You can redo the first assignment with 0 penalty. This way, I wanted you not to get so discouraged. You can see this, but also to show you that sometimes you need help. Sometimes you need study groups. Sometimes you need tutoring. It's okay. So here's it's 8 assignments. There's a final assignment. The final exam is a programming exam. And I was a student, so I would hate if all of a sudden Ed gave you a final and you have to now code on a piece of paper with a pen and paper, right? And try to code and do it right. I code with an editor, right? So it's take home.
Yes.
Right? Sounds cool, but it's you got to code. So now it has to compile because it has to run. But you got the editor, you got the compiler, you got everything in your hand. So it's gonna be much more fair. Right? And you get 24 hours to do it. So I mean, I'm truly not trying to hurt you guys or do anything like that. So there's extra credit. And we also do a final project, which is you put everything together. I'm going to give you a real particle system written by somebody else. It's not my code. And say optimize it. And you start using the techniques in that. And people were getting 7, 8 times faster. All right. So the material, the reference material, we're going to be scattering through a lot of different books, a lot of different material. I have online links for everything. So you can look, preview it, watch it online if you want. And if you feel inclined, then you can purchase one. Older versions work. You don't have to have the latest book. A version 1 or 2 old probably is much cheaper, you know, but you can also get the digital copies. When we do everything in Visual Studio Enterprise, when it used to be sold as a one-time purchase, was $11,000.
God.
It's free. You're a student. So this is like they try to get you addicted to the tool. Then when you leave, you get your company to buy the tool, right? That's one of those models. But just a mental note, last day you're a student, whenever that is, go to the website, download everything because you get to use it indefinitely, right? You just can't use it commercially. So I'm like, oh, I'm about to graduate. Download. Because like you're just like download $100,000 worth of Microsoft product. Why not, right? We're using everything on Perforce. We're only using D to L to have links for the videos and for grades. And the reason is the grades are private there. That's it. We're not doing submission there or anything else. You're going to submit like normal programmers do with the version control. Okay. All right, so here's the concepts. First week, fundamentals. We're just going to do linked lists and get us warmed up to C++. Second week is data caching and alignment. In optimization world, if you can optimize something 10%, you're awesome. 15%, you're like a god. 20%, they bring you gifts, right? So if you're in an industry like, I spent this out 5%, like, good job. You know, and Lisa's like, oh yeah, I did a 7. Like, she's better than you, you know? But if you can do it 10 or 20%, you're doing a huge job, right? So we're going to do data cache. And the assignment is really simple. It's a linked list. Of course, everything's linked list. Like the joke here is my whole class is just one big linked list, right? And the catch is there's gonna be, you know, links. And you're gonna start from the first one. You go, is that the key? Is that the key? Is that the key? Walk through all this, right? And I'm gonna give you 500,000 of these. So you do it and we time it. It takes 3.5 seconds. Now we're gonna rearrange it with cache. And it will be 12, 15 times faster. 15 times faster, not 10% faster. So it shows you how to exploit cache. And you realize most of the problem we're dealing with is about how does the processor access data and use data, right? We're going to create our own memory system from scratch. So new and delete or malloc and free. Malloc and free is whatever uses. New just puts a constructor on top of malloc. Delete just puts a destructor on top of free. So basically everything is malloc and free. We're gonna write our own memory system. It will be 3 or 4 times faster than Microsoft's, right? We're gonna do a lot of little conversions, little things, implicit conversions, converting things from int to float, how to prevent that, how to remove temporaries, a lot of little loose change there for efficiency. And week 6, we go after SIMD math. So every processor right now that you guys have, your Intel processors or AMD processors, there's a little second processor glued inside it called the vector processor. And it's sitting there idle. It's really fast, it's really strong. It can do 4 multiplies and 4 adds a cycle. But nobody uses it because they don't understand how to use it. And you have to have the moons aligned right to use it. It has to be, the data has to be aligned at this address, it has to be partitioned this way, all this other stuff. We'll use that and speed up all of that math operations. We're gonna do a file system. Loading and unloading files, or it's the same process to take a stream in and out from a network. And this is where it differentiates between grad and undergrad. Grad students are going to do it all in one pile. Remember, we're going to take 10,000 linked lists, push it into a file. They're going to turn around, read that file, and recreate the 10,000 linked lists. Grad students have to do it in one new and one delete. Undergrads can have 10,000 news, 10,000 deletes. So that's the quick. I teach the same technique to everybody. You can choose which one you want, but grad students have to do the one. Week 8 is a unit test of linked lists. I want to give you a linked list that's not in a textbook, not Googleable. So I created my own hellish linked list. Do you know how they would farm, oxen farm? They would go across, down, across, and they do the whole farm field that way. That's the way the linked list works. And each one is a node, and then there's north, south, east, and west nodes on it. So it's a truly evil list, but it's not in any book. So that's why I did it. So final project, you get a link, a particle system, and you just have to optimize it. Grad students are going to do an analysis first and a prediction of what they can do. Now, your prediction will be 100% wrong. I just want you to go through the exercise of trying to do it. Because what happens in industry, you're like, oh, please, manager, boss guy, can I spend 3 weeks working on optimizing this code? And the first thing they're gonna say is, what do I get for it? Well, let's say it takes 4 weeks. Can I spend 4 weeks to optimize this? What do I get for it? Now, here's manager. I used to be a manager and director and stuff like that. $10,000 a month is what you cost me. What am I getting for $10,000? You have to start justifying your stuff. So this is an exercise of how do you predict your estimate, put a wild ass guess, defend it, do it, and see how far off you are. I'm not grading on correctness. I'm grading on just the effort. And I think this is how you do schedules. So if you work in industry, you know what I mean. How long is it going to take you to do this? You're horribly wrong. You make a guess, you do it, then you rectify it. The next guess will be a little bit better. And after a year, you start to actually estimate your ability, right? And you realize there's no such thing as under a 4-hour task. It does not exist. Change 3 lines of code, you have to go through the submission, the verification, the code review, all this other stuff. Everything is a 4-hour task, at least, right? All right, and then the final exam is, I told you it was a take home. All right, C++, there's be weekly programming things just to kind of get you exercising different aspects of this stuff like strings, pointers, STL, vtables, stuff that you can Google, stuff you can read out of the book. Pretty easy, and they're only 1 point each. We're gonna be using Perforce, and I'll go through that today. I want you to check in multiple times, ideally over multiple days. Some people have work and other commitments, so they only work on the weekends. That's fine, but I want to see multiple check-ins and see your progression. If all of a sudden I see nothing and all of a sudden, whew, there's a perfect solution, you just are like asking for scrutiny, right? It's like the dentist goes, the checking in for cavities, like, no, let me get the sharper pick. Okay, now let's look at it, just do it this way. I can see that you're incrementally doing this stuff and developing it. We're using Piazza a lot. In the past, successful classes have had 7,000 unique posts in 10 weeks. You can't ask enough of questions on this. I'm going to create a Discord forum. Discord, it's just for you guys, whatever you guys like to do. And sometimes people like to keep chats open, they're coding and they're talking to each other as they're coding. That's cool. Problem with Discord is not searchable. Imagine 10,000 posts and like somebody said something at 2:30 in the morning, of one comment about this, and it's like an email daisy chain, right? It gets sloppy. Perforce is the one. Piazza is what I stay on top of. I have apps to read it and look at it all the time. We go through it very quickly. And what's nice is if somebody gets to the problem, we already hashed it out. Then you come back later, you're like, oh, there it is. And you can see what they did. There's a section where you can put code snippets in there, and I'm going to drive a lot of questions on there also as well. But Piazza, right? Now here's the weird thing. I have stats. I know how many times you're looking at things and not looking at things, blah, blah. But there's one thing that's true. People who post the most do the best. Just that simple, right? Because they're engaged. If they know the material, they're helping somebody out. So if you think you know it, you help somebody out, you see how much you really know. And if you're struggling with it or you're learning, you're asking questions. Either way, if you're posting a lot, you tend to do very well in the class. I mean, extremely well. Just make sure you watch the lecture before you post. All right, collaborating with others. I encourage study groups, work together, all this sort of stuff, but everything you do is yours, right? So work together, refactor it, make sure you understand every line of it. I've had students who've done really well on all the assignments because they work in groups, and then they fail the final. And if you fail the final, you fail the class. And that's because they weren't, they got help or somehow worked in a group, and I don't think they knew the material. They submitted it correctly, faked my system out, I graded it good, but then they didn't really know the material in their heart and they couldn't make it through the final. All right. Oh yeah, somebody asked about late policies. Just like the real world, you're late, it's a 0. I mean, there's not like, oh, it's okay. Everybody gets reduced 70%. There's your late policy, I guess. This is C++, we can't leak memory. If it doesn't work, or three tests work, and then it runs test 4 and test 4 crashes, I can't finish grading because it crashed the whole system. So every single assignment has an enable flag. You can turn on a test or turn off a test. So if one test crashes, just turn it off. And then the rest will work, and you'll get 9 out of 10 then. You see your grade at home. The only thing you don't see is this performance time. I give you my time so you can kind of see the reference, but do not, please do not cheat. Maybe unlike other classes, but if you cheat, I just give you an F for the class. I don't care if it's a 2% assignment, you're just getting an F because you're cheating. And the reason why I'm so harsh on this is a lot of students work a lot of hours, work really hard on this material. It's not fair to them. All right. So, we're just kind of going the order that we did before. I don't want to dwell too much on this stuff, but here's how the homework assignments work. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. All right, so right now here's PA1 and Basics 1, they're always together. Is released today, and it's due Saturday night. The reason why I do this is that I want you to come back in class and ask questions. So you have a full week to chew on it. Obviously, discuss on Piazza 24/7, all this other stuff, but you also get another time in classroom to ask questions about it if you need to, or office hours. what does midnight mean to programmers? Right? Midnight means I was up late last night coding, right? And then you're like, I finally stopped coding when I saw birds flying by my window, right? So I'm putting a date of midnight. I will not grab it until Sunday morning at 7 a.m. or later. So to me, it's nighttime. It's still Saturday. Even though it's Sunday, it's still Saturday.
Yeah.
So if you're still coding, it's like 3 o'clock in the morning, like, don't worry, it'll be in. The second rule is, and this is one that you shouldn't bank on, I have the right to grade right after it's due. But if something happens, my other classes go heavy, prepping, who knows what, and I don't grade that assignment for 2 weeks, the hour before I grade it, I grab all new and I grade it. So if you turn it in 3 days late and I didn't start grading, it will be graded as if it was on time. Because I don't think it's fair for me to wait a week to grade and say, oh, you missed by 10 minutes. That doesn't sound fair. So I always grab everything literally right before I grade it. And so if you get in before that line, you're in. But I have the right to grade it right after it's due. The last thing about grading is this, I'm giving you all the secrets now. A lot of students learn this after second or third class. I grade in order, right?
Order by what?
Order that they were released. So if you're on, we're on assignment 5 right now, and I'm still grading assignment 3, I still have to finish 3, then 4, then I get to 5. So you will know where I am. Now, I could have a Red Bull night and I grade all of them, right? But I grade in order. Yes,
Do you grade in alphabetical order?
it doesn't matter because I snapshot the whole thing and I grade it.
Sure, it's just the order they were submitted.
Yeah.
So, got it.
It takes me sometimes 12 hours to grade one assignment.
I got a feeling.
So yeah, it's pretty elaborate. Yes.
What if you like turn something in and you haven't got to your stack of grading and you had like an epiphany, like, oh, what if I went back and fixed this a different way?
Just turn around and fix it.
Can you still turn it in?
You
be like,
can
"Did
you can
grade
keep
this yet?"
changing that as much as you want. I'm just gonna say boom time and I grab it.
Okay.
So whatever is on the tree in the server at that moment, I grab and grade. So some students will like, I got it working, like, oh shit, this would be better.
Mhm. I've done that a lot.
Check it in, and if it makes it in through the gong, it works. There's the caveat. Whatever's up on the server, I grade. Put up garbage, I grade garbage. So I'm going to show you how to verify it next week, how to verify the submission to make sure it works. It will work on your machine because you got all the files. You check in 5 files and you forgot that one. I'm on my machine, different location, different zip code. I download it. I'm missing that file. I can't grade it. So it's important and imperative that you grade, you verify that you submit there. And there's a trick and a technique to do that. But some people are like, oh, but I'm like, it wasn't there. Right? So that's about it. All right. I think we gotta move on, get to some cool coding here. All right. All right. So everybody is learning stuff at different rate. It's really interesting how at first week it kind of is a shock and awe. And then it goes there. I pace the whole class. So the first assignment's like this hard. The next assignment, the next assignment, next assignment, next assignment. So, you know, remember I was in video games. I understand building and releasing and building and releasing. So, so you'll kind of see this, but something magical happens around 6 weeks, 6 or 7. The class suddenly becomes stupid easy. It's not. You're just getting it. You're now thinking the right way. You're seeing this. You're like, nothing that's as scary anymore. So it's really weird. Everybody goes, oh my God, the class gets so much easier week 7 on. I'm like, no, it doesn't. It's the same level the whole time. You're just now it's clicking. It's making sense. You're a monster now, right? All right. When in doubt, I'm totally not going to I'm here to help you. I'm not here to screw you. I think you need to understand that. I'm there to try to help you through this material. It's gonna look like I'm pushing hard on you because I'm trying to teach certain lessons and try to get you to think of this. You can get something right and you say the wrong reason. I'm gonna debate with you until you understand why it's working. Your reason might not be the real reason why it's working. So I gotta clarify that because I have to get you thinking the right way so that sets you up for the next problem, right? All right, so I've interviewed, hired hundreds of people, fired probably close to 100, 150 people. I can review your resumes. I can help you out even after this class. I have twisted and helped a lot of my students right now. And last quarter, I guess before Christmas break, I saw someone got 150 and better salary starts. Now, this is the first class.
Starting?
Yes, starting. This is the first class. Why do they give you that much money? Is that because they like you?
This is because of how much you know,
Because many people can't do this.
right?
So I'm there to kind of squish your head and make you smarter and, and make you more attractive on this, right? All right, all right, seasoned programmers. All right, so every class I show you a movie that's related to the class. I'm like, movie in programming, right? All right, so this movie I'm going to set up, it's a Cadillac DTS commercial. And so there's these kind of mobster guys going to a diner. And so there's the old guys, old crew who are seasoned, and there's the young guys. Right now, everybody in this class is in the young car. And they want to be seasoned programmers when they leave. When they leave here, they're like, yeah. And so you can look like everybody's like, oh my God, have you heard about it? Optimize is so hard. And you're like, yeah. Right. So that's where I want you to leave. And I put this video also up on Perforce for kids the video.
Pancakes, I think. I see you're driving a Cadillac.
And I see you're doing the very same.
Welcome to the world of gentlemen. It's good to be here.
The spacious Cadillac DTS, room for 4 grown gentlemen.
So if we do this right, you'll be looking at those like those seasoned guys, or like, you're not all excited because these guys are posers, right? They're like, oh, we'll go to the diner and look like we're really cool. And the other guys like, yeah, whatever, You're gonna get into that level. And you'll look at code so differently. It's I don't know, it's kind of exciting because I know where you're going. All right. So we're gonna program, right? All right, so what I want to do now is quickly go through C++ in a very fast arm wave and get us coding. Because I think you learn faster coding, right? And while I'm coding, I'm also going to do Perforce at the same time, so you can kind of see how to set that up as well, right? So C++, everybody knows Java or C Sharp or C++, and then everybody knows a little bit about pointers, so let's get it going, right? So I'm going to give you probably close to 50 different reference books during this quarter. I've read all of them cover to cover, but there's snippets out of each one that's useful. And so I'm going to point you to certain materials, certain locations and stuff like that to kind of help you through this stuff. So we're not going through a book directly per se. A lot of these materials kind of learn in the field, right? So C++ uses headers. Headers define the prototypes or the signature of it. In Java, and in C Sharp, you just write your function and you just write right there inside the code. C++ actually has it separated into 2 processes. We have a parsing process and then the backfill on that. The problem is you can doubly include files. You can include them once, twice, 3 times. So you can have one header that includes file A, another file includes file B includes A, then file C includes B, and you're like, oh, and I throw in A, and suddenly you have 2 A's in the same file. And that's going to cause trouble. So how we prevent that is we use header guards. It's basically a compiler processing to remove this. We spend too much time always talking about this, just do it. And we'll get through this a little later of why it's there. And when we go through preprocessor phase, right? So we have the classic scoping, public, protected, private, right? And in Java and C#, you would define the line. In C++, you could do it this way, or you can say colon, everything below that is private. So that makes things a little bit better. We also have in C++ 3 different types of inheritance. In Java, they only have 1 type of inheritance, which is public. In C++, we have public, private, and protected. And this reduces the scope and the visibility to the children and to the derived objects. So this is a thing that we'll go through a little bit later on the scoping and rules and stuff like this. But this is interesting. You can derive something as private or protected, and you can force the descendants to be more restricted. And this kind of gives a lot more control and flexibility. Every compiler, every time you create an object and instantiate it, there's 4 functions that are created for you automatically. I call them the big 4. You won't find this in literature. Some people call them the big 3 or whatever. It's the big 4. It's a default constructor, the copy constructor, the assignment operator, and the destructor. These are automatically created for us. We don't do anything, it just does it. But here's the catch. We do not write optimized software. We do not write optimized software. We write software. We write it in such a way to give hints to the compiler, and the compiler optimizes it. So when the compiler doesn't see these written out, it's got to assume the most conservative, slow, safe way to write those functions. So it's going to assume like, hey, who knows, maybe it's a multi-threaded environment. Maybe somebody else is using this variable. So it has to be very, very slow and conservative. So if we define it, compiler goes, that's what you want, I'll give you that. But if they define it very slow and protected. So what this means is, and in actuality, there's actually 6 of them. We'll talk about the last 2 on the last day of class. It's a little more esoteric. But what we do is we define them. So how do we control speed on a compiler, on our code? Is we just define those 4. Don't let the compiler choose a slow way. We will define it. Our definitions, though, are very interesting. We can define it on the classic, we just define the bottom and we just do the implementation. Like, this is what we wanted to do. This is what you think I've defined. Or we can set it to default saying, hey, compiler, we like your version. Or we say delete, nobody on earth can ever use this function. And if somebody tries to use it, it gives a compiler error. So why would you use the word default when the compiler writes it slowly, right? There's a subtle difference between if you don't define it, the compiler assumes slow. When you say equal default, the compiler goes, oh, you're giving me the control to write it as fast as I can, I will try. So this is kind of a hint flag. So it hints to the compiler, make it as fast as you can. We trust you. So it really isn't default, it's really like hint, please, please, please make it fast. Now, there's times where the default is faster, so there's times when your code is faster. But the key is always to define it in one of these 3 categories. Heap versus stack, right? So this variable dog of Fido right here, that's on the stack. Unlike Java, where you have to call new, you can instantiate an object on the stack, right? And this is probably one of the biggest reasons why it goes faster. When you call Java, right? So Java, you would do dog, f equals new dog, right? This is going to go off the heap. Heap equals slow. Stack equals fast. Could we in Java, we can sit there and go int x equals new int, right? But a lot of times we'll just go int x. Put that on the stack, right? This is a lot faster than the heap. So stack is fast. And what's different in Java versus C++ is that you can put objects on the stack. So the only time you need a heap is when you need to pass that pointer around. So if you can use it in the lifetime of within that scope, you do it on the stack. So a heap, we just do this classic thing, we declare it and call new. And again, we'll have the little asterisk there for the pointer. And then we use the arrows, right? So you'll see stack variables is a dot, pointer variables is an arrow. Right? So value, reference, pointer. C++ has 3 different ways to pass a data structure to a function or around. You can pass it by value, you can pass it by reference, or you can pass it by pointer, right? So here's the prototype. This is the signature. This signature is by value because you see it says dog and there's nothing else in front of it, right? It's just plain dog. This is by value, saying I'm going to copy a complete dog onto the stack, right? So here's how you would call it. I'm only curious about this function right here. We're going to pass in Fido into the function foo. Pass my value. Assume dog is 1,000 bytes. How many bytes are we passing into foo? 1,000 bytes. So by value says I'm copying 1,000 bytes. What you need to do in your head, every time you see code, linked list, pass by value, make it a big number in your head. It might be 4 bytes. Make it 1,000, make it 1,000,000. Walking a linked list of 1,000,000 nodes. When you start thinking that, then you know that it costs more than something else, right? So this is 1,000 bytes get passed in. Now we go to pointer, right? So there's a signature pointer, and we put the little asterisk in front. All right, how many bytes are getting passed to function foo? So we have 1 vote for 8. 4. Okay, so the answer is it depends. It depends on what your compiler mode is. Are you in 32-bit mode or are you in 64-bit mode? So let's kind of go, let's get into the operating system discussion for 1 second. What is the difference between a 32-bit operating system and a 64-bit operating system? 32-bit operating system says it has address space 2 to the 32, which we all know by heart is 4 gigs, right? So this is 4 gigs. That means the biggest amount of memory you can have in a 32-bit application is 4 gigs. Yeah, but I want to do move editing and I'm editing terabytes. Won't work, right? So a 64-bit application is obviously 2 to the 64, so it's a really big number, you know. So here's what they do. They make your operating system 64-bit. That means you can put as much memory as you want in there. You want to put 2 gigs, you want to put 5 terabytes in there, knock yourself out. I have 64 bits to play with. There's a little problem a couple of years ago where Microsoft actually wasn't giving you 64 bits. They kind of cheated some bits off of there and then it finally blew up in their face. But anyway, you're supposed to get 64 bits. And what they do is they say, here's our 64 bit. So I kind of think of this like, here's the 64-bit world. Then you think, oh, I want to run Mozilla. Mozilla gets this little 32-bit section. Oh, I want to run, you know, Maya. That's going to get a 2 terabyte range. So you get these different ranges. All the ranges added together can't exceed 64 bits, which is a ton of money, memory. So when we have an operating system is 64-bit, our application is one of two choices, 32 or 64. If it is 32, it's 4 bytes. So all your pointers are 4 bytes. If you're building in 64-bit, all your pointers are 8 bytes. Right? Now the catch is, to go into a 64-bit system, that means every math operation is an 8-byte operation. You know, incrementing a pointer is an 8-byte operation. Everything is 8 bytes, so it's slower than a 32. So you should never use a 64 build of your application unless you need it. So if you're doing, you know, movie editing, audio editing, I'm just thinking of like, you know, 3D modeling sometimes, that uses a lot of memory. If you're not at, if your single application doesn't need more than 4 gigs total RAM, leave it as 32, it'll run faster. Right? So the answer here is we're in a 32-bit system, so therefore the pointer is 4 bytes. So now we have 1,000 bytes for Fido, we're passing it in, but we're passing the pointer, so we're only passing 4 bytes. So now reference. We just put a little reference sign on the front here. How many bytes are we passing in reference?
1,000.
Okay, anybody else? So here's the surprising thing. In Java, what do you guys call it when you dynamically allocate something?
New.
Well, new, but what do you get back as a return? You get a pointer, which in Java, they'll call it a reference.
So how's this different?
It's not, it's a reference. So it's a pointer. So here's this shocking news. Pointers and references are the same. There's a small caveat we'll go through. So a reference and a pointer are both 4 bytes. The value is whatever size the data is. Right? So here's the shock. Here's a reference with a little ampersand sign. It's the same as a read-only pointer. When you have a reference, it says, I can't change that reference. Think of this. You take a dog leash and snap the dog leash to the dog, but you hot glue it, so you can't take the dog leash off. That's a reference.
Animal abuse.
A pointer, a constant pointer, which is a read-only pointer, points to this. You cannot change the pointer. I cannot change that dog leash. The difference is a pointer might be pointing to nothing, or it could be pointing to the dog. A reference has to point to the dog. So the only difference is its syntactical sugar. A reference is guaranteed to always point to the object. A pointer may or may not be pointing to the object, may be null or may there, but it's a read only, so you can't change it. Then they add syntactical sugar. They put a dot instead of an arrow. Same code. You can look at the disassembly, same code. So a pointer and a reference are the same. A reference is guaranteed to be correct. A pointer may not be. And this pointer cannot be changed because it's read only. So once it's written, you can't change it. So always, always, always prefer a reference when you're given a choice. Yes.
So this might be going too far ahead. So like when you're making a linked list and you're making like pointing to the next one, you can't use these references because it's something you have to run to the end of the list, or is like, does it
Well,
matter? as long
if
as
you're,
it's the end?
the kind of the deal is if you're changing the pointer, you keep it as a pointer. If you're changing it, if you're stationary, you use a reference. So so pointers, you tend to, you know, like linked lists, you leave them all as pointers. And then you just have to like code and be buyer beware. But if you're going to pass an object into a function, you can pass it by pointer, or you can pass by reference. Always choose the reference. But if you're in an object, you're holding a pointer to it, still pass it by reference. And you just dereference it and pass it. Okay, this will make more sense as we go. This is just, like I said, quick learning. All right, you'll see in books everywhere, see out. See out, see out, see out, see out. All right, in forums and news scripts, everything, they have use the word noob. See out is noob. If you come to an interview, you show code and you use see out, you will not get hired in a good job. It's just that simple. Right? Printf is more dangerous. Security guys hate it because it's totally dangerous, but it does so many more things quicker and easier for you. Remember, printing is a debugging feature. It's really generally not used for commercial reasons. Printf is so good that even Java has it now. Right? So don't use cout, use printf. If you want, we can do a format contest and show you how evil it is. Just Google it. All right, miscellaneous, we'll go through all this stuff as we kind of go through it, but there's cons, defines, all this other stuff as we go, but I want to get coding, right? All right, that's it. I just gave you C++, we're done. Got 9 weeks to kind of kick it back and relax. All right, so what I have here is I have a sandbox. I give everybody a sandbox. This is where you yeah, okay. There we go. The sandbox is code that you have to practice. You know, you want to try something out. You're like, oh, I wish I had a compiler to see if this works. Sandbox, Scratchpad, play around. In MATLAB, this is when you would open up a command prompt and you start typing some stuff and see if it works. So all you do is you double click the solution. And okay. And what we have here is you just go view and there'll be solution, and then there'll be another view output. Those are generally two windows I can leave open. And so in solution, this is the project. Here's the files. And you'll see this file here called main. That's our main. And I kind of give you a whole description of how this works, but I'll go through this really quickly here. So let me put it back to the original state so you see what it looks like. All right, so you'll get this program here and you just go in here, build, it'll be a clean solution. Then compile, build, rebuild solution. And if you have a mistake, you know, like here, int x. It's going to yell at you and you just double click on it, you know, like, there's a mistake. Even if you're in the file's closed, there's a mistake. You'll see little numbers on the side here. Double click, and that will jump you to the manual page. Oh, great, it fired up Bing. So hopefully you don't have Bing installed. And it will tell you kind of about the error. And you can also just Google the error, right? So it's pretty straightforward. Visual Studio, there's really no documentation. You'll just learn by doing. I learn something every once in a while, probably every 3 months. I learn something really different. I'm like, oh, it does that. Visual Studio is Microsoft's dog food. No, I mean that in a programming sense. Dog fooding is you eat the dog food you make. So when Microsoft compiler team's like, hey, there's a bug in the debugger, then the guy walks over and yells at the person who wrote the debugger. So they're constantly using their own tools. So that's why Microsoft's editing tools and compiling tools are the best, because they're constantly using it and they have a bazillion people on it. So it's always pretty good. And that's also why there's weird features in there you didn't know existed. Go ahead, just ask questions if you have any.
So once we retrieve it, onto our workspace, we can just mess around with it and edit as long as it's within that like folder modified.
yeah. Yeah, you could cut and paste and put another folder if you wanted to. It's in your code. All right, so you'll see over here, you can, sometimes some people do this, they have there's hot buttons you can go, you can spend a lifetime figuring out here. And yeah, so there's a lot of buttons here, and I'll eventually start noodling with these things, but you can kind of go nuts and adjust these to your liking. What I do is I keep some buttons up here, and then I redefine here and say clean is F6, so I just know, I go F6, boom, it cleans it. F7 builds it. So this way I don't have to like pull down and do this stuff. Some people have those buttons up here, you know, and then to run it. All right, so our system here, so the first time it runs through, you'll see all these things in the window, and you'll see loading and unloading DLLs and all this other stuff, DLLs, exiting, all this other stuff, right? So this is extra stuff that's not really, we're not really concerned about it. So just inside this window, after you run the first time, start unclicking it. All these choices. Just leave programming output. Now we run it again, you can see it's a lot cleaner. So this is the header. This tells you what file. So this is my information. This is what my debug information's on. This compiler, all this information tells you if you're in debug mode or not, if the tracking's on it. The tracking here starts, and then when at the end, when it leaves, it checks it. What I do is every time you call new, delete, malloc or free, I register it. I capture the name, the line, the file number. I put it into a table. When you leave, I go back through the table. If one is deleted, it's removed from the table. So if there's a table left at the end, you're leaking. It's just that simple. And I tell you which line. So here, let's do a quick leak. On my keyboard. So here's a pointer that's leaking. Right, and so now I don't call delete anywhere. So now I run it, and it goes boop, leaking. Tells you how many bytes I'm leaking. You know, you're leaking 4 bytes. Here's the location. So no matter where you are, if you just double click on this line, jumps you right to the line. Tells you what line's leaking. Tells you how many allocations. And if you want to see more information, you can double click this, and this is the whole stats. It tells you how many others, libraries, and other things are leaking. Right. So you always want to be leak free. So you just call it delete. And we're using, you can do printf. All right, so here's printf, and this is going to go to the console, which is a third window that's out here. And there it is. And there it is, right? And so if you use printf, it goes there. It's just a little bit annoying, constantly chasing this thing out here in this window. So what I did is I created a function called trace out. And what trace out does is throws it into this window here. Same interface. If you want to look up how does printf work, look it up. Trace out works the same way. And now trace out is going to print right into that window. So right here. And this is, I think, easier so you're not swapping back and forth between windows. You know, everything I do, I have up here. This is the framework. This is where I'm creating the whole environment for printf, for memory tracking. You can feel free if you want to look at it. Here's all my code. You know, you'll go nuts trying to understand it, but knock yourself out. And in here will be the trace out We'll try this again. Oh, I know why I'm doing that here. I want to see what the function looks like. This right click definition there is. So here's a trace out format. To see what's going on here, I'm taking a variable formatted ellipsis string and then pushing it into Windows. And here it is going through into the Windows screen. So don't worry about this. This is all magic that happens, but it's showing you that everything that I give you all the code. I'm not hiding anything. I'm just trying to make your life a little bit easier. All right. So this code here basically has two classes. It has a class A, and this class A is right here. Here's the header. Here's the big four. Here's a specialized constructor. Here's a binary operator overload addition, and then the data. And you can see here, I'm just going to go through this like, here's two variables, here's a print. So we can kind of see how to print. So boom, A, B. If you want to look at these variables, you can just type in your watch window A, B, right? And there's your variables. Oh, I'm sorry, it was X. Right? You can then click in here if you want to see this as hexadecimal, you right click and do this. So you can just noodle your way through this. The big thing here is there's watch windows. And there's another one here under debug windows, and it says locals. This is all the variables that are available in that function. There's another one that they do, which is auto. This is what variables they think you want to see. So it filters. When your locals become 700 variables, you're like, I'm only worried about these 4 variables. It kind of guesses what you want to see. I almost use printf exclusively because I can do a lot more stuff there. It doesn't take long to do this, or I use watch windows. So, all right. So now here it is. I'm going to declare Jane. Jane's going to use a default constructor of A on the stack. So I single step into it. There it is. Goes through the initializes the variable, and then has a print statement. And now there's Jane's created. We can sit here now and look at Jane. And there's Jane, and there's the variable 5, right? Yeah.
Where'd you find the watch window?
All these windows here, you're just going to, when you're running it, debug windows. But when you're not running, right? So when stop here, debug, and there's no windows. So it's like you have to be running to get to the window, which is kind of seems a little bit problematic. So once it's running, you hit a breakpoint, then you see it here. There's all the choices. All right, just blow through this, then we'll do some coding. All right, so here's another default constructor, Nancy. Goes in here, boom, boom. Now we're going to sit there and say this is an assignment operator. Jane is equal to Nancy. Goes into this. Here's the assignment operator. And call it dynamic allocation. So now it goes dynamic allocation to a default constructor. And then I'm going to delete, and then prints, right? So it kind of gets you up and going. The whole purpose of this thing here is to give you a sample project. If you want to play with this, the first thing I do is I just always go, all right, delete, delete, and now I start coding. So now everything's empty. And now I start coding. If you up here in this corner here is called, which mode are you? Are you building a debug or release? So here's debug, and then you drag down release. There you go. And this is going to build a release. And debugging is memory track is disabled because it's trying to run as fast as it can. It's in release mode, right? It's release or debug. If you don't have the pull down windows, you go into build, it says build configuration manager, and then you just pick debug or release. But this window is almost always there, and you can adjust this and customize it. All right, so let's start looking at stuff. All right, so here I am. I have nothing on my screen. I want to create, start from scratch, and we're going to code together and also show you how to use Perforce at the same time. All right, so let's do that. So when we fire off Perforce, you follow the instructions off of Piazza. Piazza here has set up the Perforce account. And so you just follow the instructions here. And one of the things you have to do is install the client. So here you go into this, pick your family in Windows, Platform 64, take the exe or package, and then download it and run it, right? And what you get is this Perforce thing here. Let's see. All right, here we go. So you get Perforce, which is P4V. And here, this is in the documentation, you do the Perforce DPU depaul.edu.1666, then your name. This is your Campus Connect name. I also put it in there. So I created a dummy one. And then you leave everything else empty, hit OK. It asks you for your Campus Connect password. Oh goodness, don't please. You're gonna see how I change passwords. There you go. The problem here is I had to create this temporary one. I had to create a unique identifier and name of this up. So otherwise we get my account. All right, so what you're gonna get out of this is here's Perforce. This is the server. And I'm going to tell you different names than what they use. They have the word depot and workspace. Depot, just think of server. Workspace, local, right? Server, local, right? So here's the server, and we can see here, this is what I get to see. I get to see common directory, reference directory, and student directory, right? And then here's local, and there's nothing. So what I need to do is map it, saying from the server it goes to my local machine, I have to map it somehow. So we do this as create a connection, so new workspace. And now, in here in this workspace, give it your name that makes sense, right? So this Keenan demo class 461, right? And then where do you want your root to be? Pick one direction. Make it somewhat intelligent. So for this case here, I'm just gonna go to desktop. I'll put in the directory, make a new directory here. Demo. Okay, I'll put in demo. That's it. Leave everything else the same and say okay. Done. That's it. So now when you click on workspace, that's your location. This is it. All right, you're going to do one more thing on the Piazza, which I think I must have lost. So much for remembering. Right? Yeah, good job. In here, there's the Perforce etiquette. And this is what you want to do is update these things here. And I'll go through these really quickly. All these things are to make things easier, right? So, so here we'll go into search. preferences. And there's this little question up here that says logging. Make sure the first two are clicked. And what this is going to do is anytime you do anything, you'll see down in the bottom screen, down here, it will come up on the log. So over here, you'll see kind of what's being downloaded, what's being transferred. So this is like a little bit of verbose mode. Then you go to connections, edit current workspace, advanced tab. And you go down here, it says remove, delete workspace directories when empty. Yes. Then there's one that says on submit. You want to click and says revert unchanged files. Right, so delete and revert unchanged files, apply, okay. And the last thing you're gonna do is switch to workspace, make sure it's pointing to the right one. And you see it up here in the corner, up in the corner, you'll see your name, and this is the one you're on. Okay, that's it. So now you just go to your student directory and right click and say get revision. You know, get latest, or you can click this button. I guess there's a button here, get latest, boom. And you can see everything came down. That's why the verbose is nice, where you can see it. You know, if you want the assignments, you know, in the reference directory is read only. And this is like, if you want a clean copy of the assignment, it's there. So this way, in case you fat finger it or you don't know what it used to look like, it's there. All the lectures are up there as well. This stuff here, you don't need to copy it. It lives here. Don't copy it into your student directory. It stays there. So this is reference or read only directory. So I downloaded this all. We look in workspace. There it is, right? So now what we're going to do is we're going to work on the primer. And this is going to feel kind of weird, but what you try to do is try to do as much work out of the server tab, the depot tab. You almost never use the workspace tab, right? So let's do this. We're going to work on the, so here's the code. So we see right here, and if we go into primer, let me just look at a file really quickly here. You click attributes, and what you see is these are all read only. So you see right here, this is RA read only. If we go to properties, it says read only. This is per force little marker saying it's not checked out, it's read only, don't write it. So if you try writing on it, it yells at you like, can't write it, it's read only. So the trick here to use in the version control is really simple. Mother may I. Everything you ask for permission, right? So you go to the depot, like I want to work on this. So you so here's your things here. What you want to keep is the red triangle one. This is under view, pending change list, right? You just click on this and go, you know, check it out. Boom. And now all those files are checked out. And now you can change it. So go in your code, now we can change it. So here, go into this, go into the code. Now here I can change it. And then what I do is when I want to save it, I close it and I run this clean me, because when you run something, you get this temporary directory with all kind of crap inside it. And you don't want to mistakenly check that in. So I always just run clean me. And then I go back to Perforce. Let's click in here. And what I would do is sit there and say, just revert unchanged files. So revert unchanged files. Well, this is the one file I changed. Now I check this in saying, you know, with a comment, submit. And now we look in the code here, see version 2. So you just keep checking it out. Now, the catch is you check everything out from depot, not from workspace, always from depot. And you work on the code. I'll click, work on the code. Clean me. So now when you do it here, because we did that setup, or we did that setup over here, where we did edit, workspace, revert unchanged files, it automatically does it. So we just hit submit and not worry about it. You know. And now only that one file gets read. And Perforce, you can, basically you can't screw up Perforce. I'll help you if you get in trouble, but you can't even delete a file from Perforce. And it sounds weird, like, well, you can't delete something. Let's say today you needed a file called dog.cpp, right? Then next week you delete it. 3 years from now, you say, what was it on March 31st? March 31st, you had the file dog, so it's never deleted from the repository. So there's no such thing as delete, it's marked for delete. So because of that, you can't screw up. If you somehow get something broken, just shoot a Piazza post, we'll fix it. So I can undo things that if you screw stuff up, you won't lose stuff. Because version control will always keep a copy of it. Right? So, all right, so then if we go in here, you can also click here and do file history. You can see here's the files. We can sit there and do a graph. Here's the versions. We can go through this, click and do the time lapse. Here's the code. And then I can switch it over time. You can watch how it changes. So I can get all kind of telemetry on this. I can tell you what law, what's your IP number, what's your port number you use to do this stuff. I all kind of information. This is all to kind of help us control and monitor what's going on in the version control. Right. So let's do this assignment now. So primer, what I want to do is give you an assignment that's just a warm-up assignment. Doesn't count for anything, but we'll do it together. So here's primer. Everything's going to be a PDF. And when you're done, when you're done with the project, you'll fill in this form. But all the instructions are in the form, right? Submit multiple times, write everything in C++, blah, blah, blah. So down here. So this thing is just to teach you the big fours, class and headers and framework, right? So what we're going to do is dog class has 3 private variables, int x, y, z, add a prototype to this corresponding. So there it is. So here's what I'm going to do. We look at the code. So first thing is, let's check out the code. And now here's all the code checked out. All right, fire it up. Most of the projects, all except the last one, you don't create any files. You just check in, check out, check in, check out, check in, check out. You don't have to add or delete any files. So that makes it a lot easier. All right, so here it is. Here's our project. And what we have is a directory called unit test configuration. They're all false. And so when we run this, compile it. These are all false. These are all disabled. You see they're all ignore, 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 ignore. And so all of them ignored. So what we do is turn on the first one. Yes.
Sorry, I got turned around. How did you, I missed the part with the Perforce, how you like opened up all that. So it all was like.
Yeah,
one
you went really fast, so
Yeah,
I'm literally
I'm-
trying to keep up, but I am
I'm
not,
not keeping
I
up
gave
with you.
up like.
Oh, I'm sorry. You'll to check
Yeah,
out.
Unfortunately, I don't have the reflex yet, so I was like.
No, that's fine.
I've never used Perforce ever, that's why I'm like trying to.
Question, hate to be the one to ask it, but since we are past the halfway point, are we gonna get a 2-minute break at all or not?
Oh, you guys need a bio break?
Probably. I'm speaking for the masses and I
Okay.
hate to be the one to ask.
See, I'm used to going with 6-hour lectures, so
Right, of course.
no worries. Oh, let's do the 15-minute break.
Just, yeah,
Yeah,
I figured just so we can all
Yeah.
take a quick break, get back into it.
that's
I
fine.
appreciate it.
Of course. I'll let everybody, but I gotta go. I gotta go.
I don't need that.
I got it. I'm in the same boat as you.
So I was like, oh my god. Oh, okay, so I got it and then I linked it to the thing that I follow the instructions. I completely missed the whole workspace part because I was trying to figure out.
You just have to map it to your local.
I have it set up. I just wondering how it's pulling files.
Yeah, it's-
Checking in and checking out.
So go to your, did you create a
Because that's why they
workspace?
lost me. I have it set up.
That's what you have to do. New.
Yeah, yes, I think.
Yeah,
I
but
don't-
default, so like you go to,
Now,
Hold on.
you
give
right
it your
click
name,
whatever.
whatever name you wanna call this.
We're talking inspector, there's no-
What it generally does is kind of matches your computer name and that. I just give it a name,
Yeah.
right? Then what directory, go browse, what directory, where do
I
you
want
want
to
it?
clean all this out. I want to start from scratch.
Yeah,
Like you start your work.
There's a bunch of crap in here. I want to get it all, just clean it visually and start from the beginning. So I know what that looks like.
that's it. And then we're gonna just go to.
Okay, but right now it's clone.
Advanced,
I don't know where
click
this
the
reference is
bottom
coming from. So
dot,
right now it's
remove
clone.
the directory, one above.
Right here. So now actually grab this and go check out.
Then
right?
down this one, you're gonna do the pull down,
Next.
just root,
So now
revert
it's-
unchanged files.
So when you check out, it's gonna go into like that red triangle tab.
But I don't know.
Now what do I do?
And then I think that basically makes it so you can edit it.
What are the changes?
And then go back to the basics.
When you have your workspace, it's already like down like.
All right, so now go to connections,
Check out to-
I
select,
think that's
switch workspace.
when you have it checked out, it's
Okay, so start
when
this.
you're done like editing, you have to like, I think you right click
Lots of
like
stuff.
that, and then there's a submit button, that's how you like
Connection.
submit.
That's the difference from check in.
That's the checking.
This
I
and
think
then
that's,
hit
I think
OK.
it's just many of the.
There's a separate thing that says check in.
Okay. Oh, no, is that the directory you wanted?
Yeah,
No.
like if I do
No,
here,
but
No, let's do that. So go back to this. It's fine, we can do it. Go for connection.
that's the
I
same.
think so.
Okay, so now that it's local, if I click any of this, it'll open it up individual.
No,
So now we're here in timer. Sandbox this one.
Yeah.
yeah, and then go to workspace. So we do.
I would love to see the rest of my file tree. Does it show up
In there. Delete it. Right click on that.
Like there's a whole, this sandbox thing lives in a whole project. I would love to see it here.
All right, now let's start the
Can you
scan.
see it?
No, I don't, I only have like the sandbox, so.
New workspace.
Oh, I think you can open it.
Okay, give it a name.
I mean, there's a, I only have that sandbox, I don't have like the,
Right, now,
Oh, is that, you see all that other
back
stuff?
to that.
like the,
pick
like
your
all this
directory.
inside? Oh
Yeah.
yeah, I just hit the arrow and then,
Hold on.
Directory name.
Stay slow. Oh, you're right.
yeah.
Now let's hit, okay.
Oh, yeah.
Here's the second folder.
folder items, you would choose a different.
We're in
Oh,
source
it's
files.
because you have.
Oh, I hit yes last time and then I closed it. Okay.
Sorry, what's your name?
I have notes. in there,
Marcello,
that's
nice to
all.
meet you.
Yeah, that's me.
So Cass, where is this sandbox file? That's
Okay,
okay.
and
Wait, no, you're not working yet. Go to workspace. Is that in the right directory? Yeah.
yes, yeah.
Okay, so now go to your connection. So is this right up here? Yeah, that's right. Okay, now we're in connection to the advanced stuff. Connection. Yeah, edit.
Yeah.
Okay, great.
There you go. Yeah,
Yes.
it's right, right, then advance, then the bottom box.
Oh, yeah, this and then.
And then
drop it.
then drop down to the last one, it's revert. Apply. Okay. Now, go to this directory and just say get. Student directory, yeah. Student, you have to say get. You just click your hide directory and it won't get everything underneath it. So you can click up here, or you can right click.
For which one, me?
Yeah. Just- Get latest. First one. Okay, and we forgot, go to edit,
I know the class itself.
preferences. You'll see things as logs down here.
But I took it like years ago.
There you go. And then the first two boxes check.
Yeah,
Apply.
like that's what, like they teach you.
And now, now if you look in your workspace,
And it's like a
There it is.
pretty.
Okay, cool. You said it almost never work out of here, you work out of,
no, you do check-in and checkouts from Depot.
okay,
And the thing is, if you do check-ins and checkouts out of workspace, you might mistakenly check in extra stuff. We don't want to check in extra stuff.
so to pull your sandbox to mine, what do I do?
That's all you do.
Yeah,
Yeah,
I
just
had to be
confirm.
there.
You just did it.
Yeah,
You're
I was gonna say,
at the
why-
parent level of the directory. I'm not there, I'm out there. You want sandbox? Sandbox is right here.
Yeah, I can
Oh,
get
yeah.
the vibe off of. I am not, I'm just older.
That's fair. Yeah, no, I just started.
Yeah.
This, like, my fall quarter was my first one.
Gotcha.
Oh, so it's already moved in.
Yeah.
Oh, when I
was
did it
like-
earlier. Okay, got it. Okay, I'm tracking. Thank you.
Got it.
Yeah, I've never used this before. That's why I
No,
was
you'll
like,
get it,
what
you'll
is
get
this?
it.
So we're in dog.h.
Human.h.
Yeah, okay, good. Great.
My issue I was running into with the verify install thing, it was just not working.
So it wasn't working and then someone posted a very helpful comment, no idea who.
Yeah, it was the version update or whatever,
Yeah.
and I tried doing that, and for some reason it didn't want to update or whatever. I have no clue.
Is it working now?
I have no clue. I'm about to check it.
Wait, are you talking about the SDK?
Yeah, mine was
Yeah.
working, but now I fixed it because of that comment.
That's my
Yeah, do you
comment.
mind just?
Thank you.
You're the one that commented?
Yeah,
Hell yeah.
I just like, I went to
Yeah.
the installer thing and then I could change the version there.
Okay, so you went to like modify
Look
it.
there, because I was looking like.
I looked it up, I was like, what the hell's going on?
So you went to the Visual Studio installer and.
Yeah, and then modify and then
Okay, let
any
me scroll.
individual components and then you scroll all the way to the bottom.
Yeah, I'm gonna try that real quick because,
And I think you have to use the Windows 10 one, not the Windows 11 one, because Windows 11 doesn't have one that's a version high enough,
yeah,
which is tedious.
the issue that I'm running into right now is that like, I am also taking programming languages. And the amount of shit I need to have downloaded for that is unreal. And I have like,
I'm thinking that can't happen.
I wish I did, but I also, I'm in such a weird position of all my classes. And I'm just like, I kind of have to take this one. And I just can't, dude, I don't know.
Let's go to the timing.
Yeah, it's literally the timing thing and the way my classes are working, like,
This is your first year also?
no, I'm my first year. I'm in my junior year. I'm not a grad student.
Oh, you're a junior.
Yeah.
Got it.
I'm a junior, but I came out of the military too. So it's like
Yeah, you got this job.
Are you the Air Force?
Air Force.
Yeah.
Yeah,
Marine Corps.
nice.
Okay, cool.
I just got out like a month ago. So I'm like,
Okay,
so now I'm a bona fide civilian finally.
how was your transitioning back?
It was rough. It was rough at first, but now I think I've gotten everything on track. I
Okay.
I got a place,
Yeah,
I
yeah.
have
no.
a support structure, I
Thank
know
you
what
for
I'm
being the resident
doing.
expert.
I'm just waiting for the MHA for going to school full
Okay.
time and then I'm good.
Yeah, my only
That's
main
good to
concern for this
know.
class
I've
is
been
timing,
out
because I like
since
I
July
work full time, and so I don't know. I
I'm
don't
also a
know
veteran
if they ever
liaison
kind of
here.
see
Yeah.
these
Right,
things.
right here, so
Oh, sweet.
Brad, like, you were your Brandon Carroll, the liaison, that's me.
Okay, cool.
So if you need help with any of your GI Bill stuff,
I probably will, cause I'm figuring out for first time.
yeah, I got you. I can help you out with
That's
GI
cool.
Bill stuff.
How many of us are grad students?
Oh, I am.
I am.
I'm just old.
I think about half.
Okay.
Oh, really? Okay.
I'm 24, but I'm just, Marine Corps vet, so
I'm sorry, you're how old?
24.
And you said old.
That's, yeah, I know. Compared to most.
I'm about to cough blood, I need you to chill.
I know. I'm saying compared to the most of what classes I'm usually in. I'm usually one of the oldest.
For the record, I taught your graduating class.
Oh my god.
My first year of teaching was 2014.
Good God, all right.
They didn't really like it.
Fair enough.
Yeah. So,
I'm just usually used to being one of the older students in class, but it's good to know that there's
Anymore.
like-minded.
no, I'm in my 30s.
Gotcha, okay. You feel like a baby.
My wife's on her like 5th degree.
Jeez.
Where
was like, okay.
So she's in her 50s.
So, okay, Visual Studio installer, so I can.
You have the little modify button.
Was that?
You have the modify button.
Yeah, I see modified. Yeah, the problem is because my other class wants me to have Visual Studio Community, because I'm taking programming languages as well. So like, it's so odd of how many things I have downloaded right now.
You're using Visual Studio? Your other class? Who's teaching it?
Corin Pitcher.
And you're not using, you should be using, are you using Enterprise?
For this class, I'm
No, the
using-
other class.
The other class, he didn't specify. He just
Okay,
said,
I'll go yell at them.
there's,
Because if you get Enterprise, then you can get everything else.
yeah. It's like, I need a C compiler, I need a text editor, I need Visual Studio, I need like,
Yeah, and
it's a whole bunch of stuff. It's
it's all built in.
That's
mean, the last class I took, we were using Nano or what's the other one, Emacs, so this was a little bit.
Emacs, oh my gosh, I'm sorry.
Yeah, computer systems one, Emacs.
Yeah, I mean, because I have a friend who taught me Vim, I used Vim and not Emacs, which.
Yeah, I use VI, not even Vim.
I'm, you know, less.
Version type unmodified. What is the one?
You go all the way to.
I'm all the way at the bottom. I'm just looking at the
It's
which
like
one.
Windows 10 something 0.2 something.
It's the one you're on.
Yeah, I have 0.203.
Just grab the latest.
That's the latest one.
Okay. Because I was trying to do the verify install and it still was failing. And I saw the comment that was made on Perforce about it. And it was just what version you use, I updated the version and it was still failing. I'm about to like
Well,
retry it
I'll
again.
take a look.
Yeah, I'm about to retry it just to double
All
check.
right, let's continue on. Was it been about 15? Yeah. All right, so. Okay. So we're gonna start this, Simon. So we have it all checked out of Perforce. Just right click, check it out. And there we go. All right, so we're gonna turn the first one, the first test. So out of here, there's unit tests, these unit tests here. This is the configuration. Whatever is true is run the test. Up here's a little directory called test. Here's the actual test. Right, so we hit true and this compile it. And it's gonna yell at us. Ark. He goes, okay, it's yelling, it says, okay, unused variable, double click on it, it says, here, we're in the test, and the test says unused variable X, right? So what we need to do is write the default constructor. And here is add a default constructor, initialize it to these values. Let's do that. Dog.h, we'll add the default constructor. The default constructor is it's dog with parentheses. That's it. So you're doing the prototype here. Then we're gonna go over to the CBP file and do the body. Right. And here's what's a little bit weird. You have to put a scope in there saying, all right, this constructor, whose class is it in? It's in dog class, scope it. Now we do the body here. Our variables are X, Y, Z. So it's this arrow X equals, and then I forgot what it's 99, 99. This arrow Y 98 Z 97. And we can look at the unit test and we can kind of go from there. It's like, oh, 99, 98, 97. All right, so compile it. Run it. And it's failing because I don't have, oh goodness. The machine here has an old version of Windows. They didn't update it during spring break, those bastards. All right, yes.
I have a C++ syntax question. So if under include, we said something that's like using namespace dog, then we wouldn't have to do the dog double colon, right? We could just use dog.
For using, I'm not sure for declaration. You know what I'm saying?
I know.
And I'll show you in a second. Just declare it right now this way. Don't get ahead of your skis with the using yet. We'll use using later.
Yeah, no, I'm determined to not bite off too much.
Yeah, I'm gonna keep pulling you back. Wow, this is an old version of compiler. All right. All right, cool. It passed. All right, so that's our first test. All right, so now we do, so now we want to check it in, check it out. We just leave everything here. If we do everything through the depot, with depot tab, we just go in here and say test 1. Pass. Submit. Boom. Turn around, check it back out. Check out. Boom. All right, continue on. That's it. So now, oops, now we go to the second test, which is specialized constructor.
Did you check it back out from the workspace? Or from the-
No, I do everything from the depot tab. Depot tab.
So the depot tab will know when something changed in the workspace, so you can just say.
Yeah, you don't have to, the only time you ever have to go to the workspace, the only time you ever have to go to the workspace is to add a file. Which shouldn't be the case in this class. You all, I give you, I basically get all the projects stubbed out where there's empty files, so you don't have to do add and delete. Because the add and delete sometimes confuses people, so you don't ever have to do add or delete. So just on depot tab, check it out. When you're done, check it back in. All right, so I'm doing the unit test config. Switch this to true, compile it and run it. It yells at me. Says no overloaded operator, it takes 3. Double click. There it is. I need something that takes on 3. So now I go back here. See, I need a specialized constructor that takes 3 variables. So now do a specialized constructor. God. Int. X. Int. Y. Int. Z. Why am I doing the underscore int x in front of this? These variables are optional. You don't even have to put the names of these, but I always put in there. Because I'm using the variable x, y, z here, I want to say underscore x to kind of tell me that they're inputs, not output, you know, like not part of the class. So now I want to implement this. So I'll kind of paste this. Right. Now I have to add a scope to this, scope it. There, and now I need to implement this. Right, so now compile. Run. So now 2 tests have passed. Go to Perforce. Submit. Test 2. Submit. Back to depot. Check out. Boom. Go back to code. Now I go here, turn on the next one, copy constructor. It will yell at me. And so this is the pattern from, you know, now we can sit there. I have this all written down here. The next thing you do, next thing you do, next thing you do. I'm just going by the test. Right, so, so this run this and it goes. Copy constructor worked, right? What's interesting, the copy constructor worked, and guess what? I didn't write a copy constructor. Remember when I said that the 4 items are automatically created? So the problem is I don't like this, that it worked, right? So what I want to do is I want to put it into a known state, because if I tell it to go in a known state, so obviously I like the default behavior. So why don't I just make it official? You know, say mom and dad were officially engaged, right? So copy constructor is const dog reference. I'll say equal default. And now compile it. Right. And that works. Go back to Perforce. Submit. 3. Boom. Check out. Now go to the unit test, bump up to the next one, number 4, assignment operator. Right. So the assignment operator here is dog. Right here, let me just compile it. So this works again because that's a default behavior and works. But for practice, let's do our own. So it's dog reference operator equal, yeah, this is equal con reference. And now we implement this. And this is a little bit tricky because now we're returning something. Yes.
Sorry, I really need to slow down. I cannot possibly, I can't keep up.
Well, it's just not designed that, I'm not designing this tutorial right now that you guys code with me. Because if you're coding with me, you're not learning. Sit back, enjoy the read.
Let's say, I don't think I can keep it.
Yeah, no, first of all, and I'm coding at 1/4 speed.
Okay.
Yeah, if you want to see me code at real speed, it's even faster. No, the reason here is I don't believe in you coding with me. I think that's a horrible idea. Whoever came up with the idea should get kicked in the teeth. The reason is, what's happened when you're coding with somebody doing a demo? What's the next thing? What's the next thing? What's the next thing? Why is it clown, right?
Yeah.
You don't understand shit of what you're doing. Right? And then it's like going, oh, this guy got it coded. What did I miss? All right, type in these 3 lines. Okay, now I got it working. Did you learn anything? No. Stop, relax, enjoy. Right? So we're doing the assignment operator. The assignment operator. So these instructions here, the signatures, you'll eventually start to know. If not, you're gonna have to look these up. So what's kind of a thing that say the copy constructor has this const dog reference. It's the same input argument as the assignment operator. Right? So they're the same. So then when we implement this, we need to scope this, and you scope after the return. It returns a reference to a dog. So you scope it here. Now, how this works, here's variable R. So to do a copy constructor, you have a couple different things. This one here goes this arrow x equals r dot x. Oh man, you can totally tell I'm using my keyboard. Right, and so this will gives us stuff, and then when you return a reference, right? So you return a reference, so it's return star this, because you always have this pointer hanging around that gives you access to the internal variables. But you dereference a pointer, it becomes a reference. Right, so we dereference it on return. Yes.
So we're returning a reference to a dog, it's dog ampersand, not dog star.
It's no, that always we return a pointer.
Oh, I see. Oh, okay.
Yeah, you can return a reference or a pointer.
Got it. Yeah.
Yeah, those are types. So, okay, so this works. All right, so now let's do the next one. We're going to do destructor, right? And so the destructor is just this tilde dog, right? There's a destructor. And now our destructor here, right? This is where you release memory. And we're not releasing the memory because we didn't create a memory. So you look in your constructors, like no memory was created, so there's nothing to release. So here I always do this. Keyboard. Nothing. And this way, it's stubbed out. I know when I was doing this, and I'm telling myself that I chose to do nothing. It was by accident. Okay. So now the next test here is get. Right. And it's yelling at me because I don't have this function. So here's the signature. Get X, get Y, get Z. So. Pins. All right, so I put a const on the end of this, const on the end. This is telling me that this function doesn't change the internal variables. So it's a constant method. When you have a trailing const, that means you're not changing the variables in there. Right? You don't need this, but every little hint you give to the compiler, the faster it goes. Right. And that gets us a little bit further. And now we're missing the Y and Z. So this is pieces. All right, so that all passed. So go to the next test. I'm not going to keep checking and checking out. Let's go through a little bit quicker here. So set's complaining, or I like to say bitching at you. So now we do set void. And then we're changing the variables, so not constant anymore. Right, so there's those three. So I'm seeing we're just slowly marching through this. And then the next one is pass by value. True. And what are we doing with pass by value? Pass by value. We're going to, set it by value. Got it. Here's a signature. And so it's by value. So now we're going to access it by value. Let me do it discreetly. So now the next one is by pointer. So what we're doing is we're just slowly kind of exercising, and I wanted to kind of go through it really quickly in class. And then I got 2 more functions to do, and then we'll go after the homework. So there's by pointer. The last one's by reference. Oops. Okay, so pointers might pointer may not be valid, so we should do an assert here. So assert pointer is not equal to null pointer. This way, if something happened, we can be alerted to it. Oops, gotta scope it. This is by reference. And you can see right here, this is a perfect example. Here's a pointer. These both behave, this line of code is the same speed as this line of code. Pointer gets copied over, or reference of the object gets copied over. But because the pointer could be null, we have to check that and make sure it doesn't explode. So you always prefer reference. Oh, did I break something?
I don't think you're calling dog or set by reference.
Oh, yeah. Let's scope it. Yes, this, you gotta shout, I can't see.
How'd you do that cool trick you like
Alt,
simultaneously tap
alt
across all?
button, alt, and then drag your mouse.
That's very cute. I like
And
it.
then it will only, you replace inside that window. And oh, by the way, I was using this stupid editor for 25 years. I learned this like a couple of years ago.
I was just like,
And
wow.
the catch was, I'm like, what just happened? You know, like I accidentally did it. And some student goes, oh, you just hit the alt key. I'm like, okay. So there's a lot of secret tricks that Microsoft layers in there that it's not obvious.
Yeah, I've never seen that before. I was like, is he a wizard? How's he doing
Yeah.
this?
So I assume that later on, there's a reason for splitting up the
Okay.
declarations and of the class types.
Well, that's just how the compiler works.
Oh,
Yeah, it goes through a pre-syntax phase and then compilation phase and glues it together. And oh, they go by ref, so I use the full word. Yeah, I'll just leave it there. All right, so boom, see, boom, all 10 tests are passed, right? And then I'll check it in Perforce. All done. Boom, right? Now we can look at the code here and you see 7 versions of the CPP, and I can go look at it over time. And it's like, here's the code. And I can go and kind of watch it breathe. I can check the revision. So like it was born here, and then rev. If I branch it, copy it, delete it, I can see it from the tree. So I got all kind of ways. So once you start using version control, you start seeing more and more things you can do. And what's nice is if you get something working, check it in. you fuck up and you're like, I can't fix this anymore, but it used to work an hour ago, it used to work 2 days ago. Go back to the old version, grab it again, start working. That's where the win is. For individual development, the win is check in frequently. So this way, when you screw up, you know you have to have safety. Right? Because you're like, all right, well, screw it. If I lost my last 2 hours worth of work, that's okay. Just at least the other stuff was compiling. You know, I got 8 tests working. Now let's pretend one of your tests blows up. Just disable that test. Let's leave that test off. And then the last part is how do you check it in? No, we'll talk about check-in next week. All right, homework. All right, so that's it. Kind of gives a quick and dirty how to use Perforce. So let me get out of this. And it's really should not be that hard. And now people will have a lot of trouble. Please ask, watch the videos, do some demos. Also tutoring knows how to do it. All right, so now let's talk about the fun part. So that was just a warm up. So here's the all right, so PA, right? As promised, everybody knows linked list, right? So this is a linked list problem. And the linked list problem is it's really simple. It's a hot dog stand, right? So what do? You can sit there and say, I want a hot dog. You have ingredients, relish, pickles, hot mustard, hot peppers, right? And what I'm going to do is give you an integer for that. And that integer is here's the hot dog, sorry, hot dog. And you get an integer of condiments. And your condiments, these are your choices. Right? And what they are really are bit fields. Each one's a different bit. So if you want relish, you turn on the relish bit. If you don't want relish, you turn off the relish bit. If I say add relish, you add, set the bit. But if I say add, you keep setting the bit. You don't add the number, you set the bit. Because if you add it twice, the binary digit will roll over and now all of a sudden you got a different ingredient. Like going, wait a minute, I added two pickles and then all of a sudden I got a tomato, what? Right, so each one is a field. So instead of me having, 12 fields, I just have one integer and that's compacted. So this is forcing you to do bit setting and bit clearing, right? Use the old stuff from systems class, if not start a thread on Piazza. You just do it, you're doing set a bit, clear a bit. That's all you're doing. You're in Chicago. Chicago's hot dogs are serious business. You should never have ketchup unless you're a kid or you're in the suburbs that don't know better, right? So everything, when you say in Chicago, it's everything minus ketchup. And if you look at the everything is FE, because the last bit is ketchup, right? So, all right, so there's your hot dogs, right? Well, now you need to do something. Well, you have an order, right? Well, I want a hot dog with hot peppers and mustard. So here's my first hot dog. Right? Then I want another one. So here's the order for Ed. And we start adding them here. And I want 3 hot dogs. I'm hungry. And this is mustard. Relish. This is peppers, onions, and this is peppers, onions, and mustard, right? So now I put them in a linked list. And this is what's interesting. A lot of people don't look at linked lists correctly. So let's look at trying to think of something like marbles, right? Or God, I got to pick something that I even know about. That's even older than me. So let's say you have, it'll eventually hit me something. Let's just say you have like 10 phones that you want to put into a box and send it to somebody else, right? The phones are the individual items. And you're gonna put the phone into the box, into the container, into the holder, right? So the idea is that the holder doesn't create the hot dog. Somebody else creates a hot dog and you hand it to the holder and the holder holds the hot dog. So think of this as loose change. You have, here's a hot dog, here's a hot dog, here's a hot dog. And somebody calls new on it. And you're like, okay, here's the order. And then you're like going, I want you to add this hot dog. I'm like, cool, I add it. Now that means there's a pointer to that hot dog. Technically speaking, it owns it. And then this hot dog has a next and a previous. Now I want to add another hot dog. Add it. Now I have to add it into the list. This guy points here, this one points here, this points to null. I want another one. Boom. And a lot of the problems people have with linked lists and any of these data structures is they don't have the right picture or an eraser that works. You bastard. All right. Right? So all of our linked lists are 0 terminated, right? Every node counts. We don't have dummy nodes on the end. That's too undergrad, right? That's too like freshman level. Every node counts. So this order owns, that's what this diamond means. This technically means composition. And what it means is the order owns all those hot dogs. So if I'm standing there with a bag of 3 hot dogs, right? And then somebody, and I walk into a manhole cover and I just land into a shredder and I'm shredded, right? What happens to my hot dogs? Hot dogs get shredded. So when you delete the order deletes all the hot dogs. That's the ownership. So the order owns the hot dogs. Right? So we create the hot dogs loose, and then we attach them. And then if we delete this guy, we have to delete everybody. Where do we do that deletion? We do it in the destructor. So in the destructor, you have to walk the linked list. Say, delete this one, delete this one, delete this one, delete this one, right? That's it. Nothing else, right? So hot dog, what does the hot dog delete? Well, in a hot dog, the hot dog only has, it just has the ingredients or condiments, right? Condiments. It has nothing dynamic. So if you delete a hot dog, you delete a hot dog, right? But we now want to put this hot dog into an order. So here's the order. Right? What are we going to have on the order? We're going to have the head pointer. What does it point to? Hot dogs, right? So I want to move this out because it's a little crunchy here. P head. This is a hot dog. Right? Initially, it's null because there's no orders, right? So then I go, okay, here's a hot dog A. I want to now add it to the order, right? What do I need to do? I have to add it. So there'd be a function called order, add hot dog, right? Order, add hot dog, right? So just like you think, add a hot dog. But when we look at this, we want to add it. Okay, cool. We add it. Well, it doesn't have any pointers. So we need to add pointers to this. Next. Previous. Hot dog. Right? Now when I have the pointers, now guess what? Now I can add it. Get rid of this. And now simple enough. So so every hot dog has to have a next and previous, right? So in here, even though I'm telling you that you should have it, your hot dog should probably have a next and previous. So add a next and previous here in the data to make it work, right? So cool. Now we have this. We now have an order that has multiple hot dogs. Okay, this is an order. What does a hot dog stand have? Well, it takes multiple people, multiple orders, right? So we now think about this as do it this way. Here's the stand. And then it points to the first order. And if there's another guy standing in line, there's another order. And then another one. And then it terminates. But each one of these guys might have 0 too many orders. Yeah. So on the order, what do you need? You need a next and previous order. Otherwise, you can't glue it to the stand, right? And that's essentially all we have. So the hot dog problem is you have a hot dog, order, and a stand. You have the names. Each person's name can order, I'm not gonna let you type in a string. You're just gonna have a name. The selection of names are right here. I was watching Game of Thrones. Right, so here's the names. This is the names. What are our condiments? Here's our condiments. And what can we do to the hot dogs? Well, here's explanation why you should not have ketchup on a hot dog. So in case you guys are wondering. All right. Order should have next and previous. Stand should have next and previous. I mean, next and previous are in the order. Next and previous are in the hot dogs. Okay. All right. So what can we do to a hot dog? We can. Here's the link list.
So what object type is a hot dog technically? Is that just?
It's a type hot dog.
So it's really just a custom type, okay.
Yeah, I give you I rough them out. So
Oh,
that
alright.
if you can do this up, we can see how it is. Now, here's the catch. I'm mean, I'm evil. I make you do things, right? So I will sit there and say, create an order, add a hot dog. Nah, I don't want that hot dog. Delete that hot dog. No, add 3 hot dogs. Boom, boom, boom. You know what? delete the order. Boom. Add an order, create the hot dogs, create the hot dogs, create the hot dogs. So create 3 hot dogs, give them to Jamie. Create 3 hot dogs, give them to Sansa. Create 2 hot dogs, give them to Cersei. Hot dog stand. Cersei's done, delete Cersei. Sansa's done, delete Sansa, right? So go through that. Might have another thing where it says, here's a stand with 4 people. Stand burns down. Right? So what you do is, think about this, stand burns down. You call delete stand. What does delete stand goes? It goes through a destructor. It goes delete order, order, only order. Then order goes to its delete, it goes, oh, delete the hot dogs.
Oh, okay.
Right? Now you're starting to cook with gas. Yes.
Just to make sure I understand, so you're gonna create these like free floating loose hot dogs and then there's a separate attachment.
Yeah, I'm gonna create those. So you're responsible for no news, you're responsible for the deletes. So now let's look at the unit test. Same as before. So here's the test, you put true and false. Right? So here's the hot dog. Here's the functions you have to implement. Right? I think I have a print. Do I have a print statement? Or did I screw that up? Yeah, I screwed that up. Should have deleted this. Yeah. All right. Delete the print. There's no printing. All right. Hot dog. Yeah. All right. So here's the code, and you'll see this word Azul replace. This just shuts up the compiler. This just shuts up the compiler. So delete all this and code. That's it. That's how you would do this. Delete and code, right? You can add methods. You can add methods. So if you want a helper function to help you with this, add it. No templates, no containers, anything else. You're doing this from scratch. Yes.
So, because if you like look at a Java linked list, like most of the time you'd have like to tell what node you're on, you'd have an identifier. So for the orders, that's
No. You follow the instructions and do this stuff. There's no identifier. There's no. This is number 3.
Right, okay.
You're gonna do this stuff. So let's look at this. Everything you need to know is in the unit test. So let's look at the first unit test. Let's go through unit test. First one, condiments. Here's a hot dog. Add everything. I'm checking to make sure the bit pattern equals this. I'm telling you right there, like, here's how I'm checking. Then it says here, hot dog, add mustard, add sport peppers. It better equal this number. Right? Here's one, add these 3, right? Then you see a little bit down here, add everything minus relish, because Aria, it's going to be difficult. Add, minus sport pepper, add everything, do this, so you just follow instructions and your answer should be this. This tells you the bit patterns for the condiments, right? So now the next test, right? Builds. Do a default constructor. And now I'm checking to make sure your next and previous and your condiments are correct. Then do a complicated copy constructor. I'm checking to make sure the data matches. Then do an assignment operator, then do a destructor. Then hot dog. Create a hot dog, right? Add the ingredients, create another hot dog, add the ingredients, create another hot dog, add ingredients. And what you're gonna do is when you create the thing, you're gonna add it to Jamie. So here's the new hot dog was born. I'm gonna hand it to Jamie. Now it's Jamie's hot dog. It's now Jamie. When Jamie deletes it, Jamie has to delete it. He's in control of it. Right? So you go through here. So now you look here, it says hot dog. The first one is 4 hot dogs, right? It's hot dog A3, B3, C3, and D3, right? Now I check to make sure your linked list is right. You will be amazed by the amount of unit testing I do for you guys. And I'm trying to check every corner case. So this way, if you make it through it all, you're working. So I'm checking, is the first hot dog off of Jamie, is it equal to D4 on the ingredients? D4 in ingredients. Who was D4 in ingredients? Hot dog A. Then the next hot dog should equal ingredients DD. And that's the second one. So when you add, you're adding to the end of it.
Okay, so that's kind of what I was asking. I see.
Yeah. Now, is it a circular linked list? No. Is there a tail pointer? No. You walk and then add to the end of it.
Right, so yeah, I get it now. So the orders themselves are just the name of the person. Okay.
You're just gonna keep adding to the back of it. Dunk, 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 dunk. And I don't have tail pointers and I don't have circular pointers because I want you to walk and then drop it in. You know what I mean by walk or iterate through to the next. Empty, add it there. Right? So just follow instruction, you know, they're all right here. So now I just did hot dogs. Now I'm gonna sit there and say, okay, take a hot dog, add. And I'm checking the order. I'm checking that the null pointer is in the right location. I'm checking the previous pointers are right. So I go through all this stuff and make sure. So I'm just going through that. So probably the thing to do is probably do add before remove. Let's see if my unit test would have me. Nope, it's probably, I would probably run the add test before I do the remove test. All right, so then let's go to the order. Here's the order. The name is unknown, name is aria, and kind of go through this stuff. So I do all the big constructors, the big four. All right, so here's a copy constructor. You know, and so forth. So it goes through all the big four, then we start removing and adding, and then we have the stress test, which is, you know, here's Jamie's order, multiple hot dogs. Here's Cersei's order, multiple hot dogs. Here's Aria's order, multiple hot dogs. Here's the Stan Sansa order. Then I'm gonna do an assignment. So Samuel wants whatever Aria's having, so you do an assignment. That's an assignment operator. So assignment operators and copy constructors have this concept of a deep copy or a shallow copy. You guys probably heard of that? We're doing deep copies. Right? So we do that. Then towards the end here, we start deleting one order at a time. And I mean, I just keep going with all kind of edge cases and tests. And when you're done, it passes all 8 tests. Yes.
Just so I'm clear, and like, we could change the .h files to like add more helper functions if we.
Yes, you can add as many helper functions as you want.
We don't have to, really the meat of the work is in the .cpp files.
Well, no, the helper function are prototypes. There's no code in headers.
Right, that's my
So-
point, like, we don't need to change the .h files, because they just are essentially power declarations.
Well, yeah, they're just defining the prototype.
Right.
So you can add a helper function. You add a helper function here. So what I would do here is helper function. I would go like this. Private. You know, void. You know, priv. You know, helper. And blah blah blah. And then that'll be your signature. Because there's no reason to make it public. And then inside the CVP file, you define it. Then anywhere else you can use it. Yeah. But just don't do an implementation here. So what you need to do is add the next and previous, add whatever helper functions you want, if you want them. Suggestion, I think you probably should create some helper functions. I did. And that's it. It's just a linked list. Nothing that hard, but this will like destroy some people. It's not supposed to be. We're adding and removing, right? Okay. I know you guys know about this, but just to remind you and hit you over the head. So here is a linked list. A, B, C, D. There are 4 deletion states for this. So catch here is you do this one, and then let's see, will this work? No. All right. All right, so we just delete the middle one, right? Then we delete the last one. Just delete the. Delete the first one. Marker seems to go weird here. So by deleting these in a certain order, you can test each of the edge conditions. So the first one means on either side of you, next and previous of you are valid guys. You're deleting the center. Then you start to delete, okay, I delete the last one. So my next doesn't have anything. Right? Then I delete the first one. The one before me, the previous has nothing. Then I'm the only guy. And if you can handle all four of those, you can handle any type of linked list removal. And so these four conditions are in the unit test. I'll like blah, 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 and I'm like, delete this one, delete this one, delete this one. And I'm checking all those four conditions to make sure that it's valid.
So like in Java, does the first,
First of all, there's no like Java. It's coding. I'm gonna keep you on a point.
yeah,
So we're talking about in data structures, we're removing a linked list.
yeah,
Continue.
yeah, so like with, if you deleted the first one, you need to set that pointer from the order to the B, correct?
So we talking about like right here, this is just a linked list, right?
Yeah,
And so now we're going to delete C, then we'll delete D, then we'll delete A, and then delete B.
so when you delete A, you just, okay, I guess.
So what I would suggest is create in your sandbox this pattern for, and just say, okay, now delete C. Now delete D. And you'll see the edge conditions. All I'm doing is testing your remove function. Your remove function has to be well behaved.
Yeah, it's just that, because, I guess I'm thinking of it in a weird way of how, I'm already starting to think of how to do it, is why I'm confusing myself.
Yeah, no, just do it. We're always deleting by pointer, not by number, not by name, by pointer. So like here, like when you see delete D here, right? The code will look like this. I'll go to the easier one. Remove a pointer. Dunk. And that one gets deleted.
Really, is that,
That's how you do it.
oh,
That's always been done. So you can see right here, here's 4, and I remove C. I'm even showing you the diagram. Then down here, remove A. Okay, the first one. Okay, remove B. Okay, remove D. It's remove by pointer.
that makes so much.
Because you
more
got the
sense.
pointer, and you're like, this is the guy on the right, this guy on the left, or this is next and this is previous. Right?
And it just knows to keep the integrity of the linked list then?
You're in control of everything. So if you screwed up, trust me, it will yell at you.
Okay, yeah, so it's just.
Yeah, this test is unforgiving, right? So to give you an idea, when you run this and you're done. So here's mine. This is show you, every time you see the word check, I'm checking to see, is this pointer this or this value this, right? It kind of gives us a figure of merit how scrutinized I'm going, right?
Right,
Oh, I was saying, I just got bit by my own thing. One second. This computer has old drivers. There you go. All right. So in doing this here, I did 900 individual checks.
Oh,
It's just double linked list, and I'm like checking every little nuance there to make sure you're straight. Yes.
Question. So this is a question more about like C++ syntax. What I see use the const operator like a couple different places, and I'm not sure how, like, what's the difference between putting const in different places does to the function.
So we're so in
There's some
here,
you put it like get current orders const, and then sometimes it's inside the parentheses, sometimes it's before, like in the
are you talking about
return,
in the unit test?
or just in general.
It's better if I got an example, this way I can kind of
So I'm looking at like stand.h.
stand out. It's great, thank you.
Right. And so you have a few instances in the public methods where you have const inside the parentheses, you have const after the fact.
Right, okay, so,
And then right below it on line 25, you have const in like the return section.
right.
Okay.
Okay, so what this is basically the const says it's read only. So when it's on the tail, this is not gonna first of all affect you guys, this is more from a performance standpoint, and we actually talk more about it. But what's on the tail that says the variables don't change. So when you say get, give me X, give me Y, are you changing X or Y? No. So we can just say the word const on the end says all the data inside this class doesn't modify. That's what it says. It's just the class is read only. I can hand you copies, but the class itself is read only. So that's what the trailing const is. This is const methods, right? This just says return a we're going to return a const pointer. And what it says is that pointer is a return, and I'm not going to change the pointer. So once I initially tie my dog leash to something, I can't untie it.
So that means when, like, if you were to do like a declaration in somewhere else where you use.
Somewhere else I want to change the variable, it goes, you can't change it.
So you would say like const int, whatever it is, or const pointer, whatever.
Yeah.
Equals this.
So from this perspective, you don't have to really worry about this. Just return the pointer and it will just work.
And then when it's inside the parentheses,
Inside the parentheses, again, it says, this says,
like I'm reading only
This-
from that object.
yeah, this says right here, I'm an order that is a read-only pointer pointing to mutable data. So basically, when I say pointer const, it's effectively a reference. Kind of behaves like a reference.
Like you do on line 20.
Line 20. There's that, yeah, I was talking about line 20.
Yeah.
Yes.
so then like line 25 would be
It returns a read-only pointer.
oh, well,
The
yeah.
pointer itself is read-only. So here, let's look at this.
I
See this
because that's actually getting the,
right here? So there's the function. Let's show you where we use it right here. P. This points to dog, right? I can't change then dog later, P dog.
So while the pointer is immutable, the data.
The
on
data
other side-
is, you can change the data all you want.
Great, okay.
because the pointer stays the same.
So this thing about the pointer is a number and we put it in plexiglass. What it points to, you can change all you want, but that plexiglass is still plexiglass.
But it can point to a different data point.
You can,
I mean, I guess.
I'm pointing to this phone,
Yeah.
right? You can change anything in this phone, but I can't change. My point still stays with it.
Oh, position you're pointing to is.
So you can't change my arm,
Right, okay, I see.
but I always point to the phone. And so it's read only. The read only, I put that in here for more optimization purposes. Don't worry about this yet. It'll make more sense. But here, like get orders, let's return the number of orders. Let's return the peak. You know, that's all you're doing.
Then head is the first hot dog in the order in the list, correct?
What about the first?
The head is the first,
You're adding to the end of the list.
no, but when you get head, like,
Get head is what it is, the head pointer.
okay, that's what I thought.
What do you guys call the first pointer of a linked list?
First is, at least that's what in the past, but I never heard head, so.
Oh,
that's fine.
it's historically called head,
Separate.
right? You also heard of like headwaters, that's where the river would start,
Oh, all right.
you know, so yeah, it's the beginning. All right, so this is only the first assignment. This is the PA, so this is worth 5 points. Now you have another assignment. And the other assignment is basics. And did you guys do overloading binary operators like the plus function and the subtract function? Well, this is it on steroids. So this one here is, all you're gonna do is do the basics and you're going to refactor these two functions. One is monkey. And this is just overloading. And the key with this is yeah, cool. Do I have the links? All right, I will give you the links. I haven't put the link up there yet. All right, so I give you this link list here. All right, so here's a website with a lot of books. So here's all of our kind of C++ links. So as I discover something or find something, I give you kind of the search results here, so it saves you a little time. So here's all the books. You go to this one here and you can go into any of these books. But what's interesting is down here, there's a book, there's a section here, a link called Nobody Understands Overloading. This is the signature of every function you want to overload. So how do you overload the plus operator? You look up here, it's like, okay, plus operator, there you go. That's the signature. So if it's inside a class, this is the signature. If it's outside the class, this is the signature. So on this assignment here, all you're gonna do is do an overloading. So here's the overloading. And the first one is monkey. You're gonna create the get X, get Y, you know, get status, right? Here's the nibble class. You're gonna overload nibble plus constant, constant plus nibble, nibble plus nibble, nibble plus equal nibble, you know, the plus plus operators, and you're just gonna overload it and follow the instructions. So it's just forcing you to learn how to do the overloading functions. And this is stuff that you look right up, you know, it's right here in the link. You can look at the demo code on this stuff, and we're just gonna overload it. And the idea is that when you do this, we're gonna, you're gonna be a little more comfortable with all the signatures. So when you can overload a function and do stuff like this. So let's talk about nibble. How many bits are in a byte? 8, right? So, right, so what is this? This right here is this is D, and this is 5, right? This is, so this is a byte, and then this portion right here is 4 bits. 2 nibbles equal a byte, right?
Oh,
So a nibble in this case here is spelled like this. All right, so what you do is you have, I created a class called nibble, and the rules are it's only 4 bits. I give you 8 bits, but you have to live in 4. So what happens? What happens? You can go a nibble plus 3. Okay, there it is. And if anything goes over, it gets truncated off. So your storage, come on, mouse. Come on. So you're creating a 4-bit things. if it goes over 4 bits, you get rid of it, you mask it off. So if the number is 10 and you add 5 to it, it's 15, that's represented, right? So here's number 10, right? 10 is 1, what's 10? 0, 1, 0, right? So there's 10 in bit form, right? Now if we add 5 to it, 5, right? We get 15. Right? That's still nibble. Now if I say add 3, right? Add 3, right? 15 plus 3 is what?
18.
18, right? So we get 18, right? Minus 6. So we get 16. So we go 16 here, right? So now we get 2 left over. This is all you display. You're masking off anything that goes over it. So what you do is you add, then you just mask it and keep the last 4 bits. And that's what you store, right? And then it gets a little more elaborate. I'm gonna do shift. You shift, then you can wrap around. I make it a little bit more interesting with you. We're going to change what a plus operator does. Like you just say plus operator, it'll just add 3, even though you said plus. Just to show you that with overload operators, you can do anything. You do a lot of malicious things, right? And this will kind of help you learn a little bit of that stuff. So this is the minor problem. You just look at it. If you follow this instructions off the website, this is the hardest part, getting the right definition, and the rest becomes pretty easy. So that's the basics. Yes.
All these are due, not this Saturday, but the
Following
following
Saturday.
night, all 3.
There's only 2.
And they're the hot dog stands,
The hot dog is all one. Hot dog stand is all one.
right, but then there's the primer.
No, the primer we just did in class,
Oh, I see.
just for
That's not
fun.
an assignment.
No, that's just for fun.
Okay.
Yeah. But you should probably look at it again, just to kind of get your hands wet.
Understood.
The primer relates to hot dogs.
Understood.
Oh, no, that's just true, period. Yeah, it's not even a hot dog stand. Okay, so that's kind of the gist of this. It's not that hard. This assignment clobbers people for some reason. I don't know why. It's more because I think maybe they're linked lists. So an idea. You're comfortable right now still in Headspace, you're still comfortable in Java. Maybe do a linked list in Java. And then now you're just like, okay, I know that works. Now, how do I translate it over here? But the difference is it's just arrows or dots. It's not much different. Questions? Slowly and steadily, this will start making more sense. But this first assignment is just linked list, adding and removing. It's not based off performance. This is the only assignment that's just correct or not. So you know what your grade is because you're running your unit tests. Yes.
So are those links you just posted actually just the links to the books that we have in the class?
Yes, I have all the links to the books too.
Oh, great, okay.
Yeah, it's up to you, how much you want to use of those. I know I have them somewhere here.
It's always nice for reference and.
Yeah, that's what I tend to do.
150.
So, here's the programming language book right here.
Oh.
And what you have to do, and this is weird, and let me show you this. You got to click into the first link, type in your login goo. If you get it right. Might be DPU, right? There you go. All right, and then here, once you open this up, now you can go back. And you can click your choices. Now you can click like, oh, here's this book. Now you can click it and it works. Don't ask me why it's that pattern. So then here's the book, And what's nice is not only for this class, but for other classes, when I was in undergrad, what I did is sometimes you ever go to a class and you're lost in the classroom and then the book is a little bit confusing and you go to the teacher and the teacher's like, privately going, just do this, and you look at her, he or she, whoever the bookshelf is, I scan the books and I go, that's the book he took when he was an undergrad. Then I would go buy that book and like, oh my God, it matches the notes and everything looks the same, right? So I found that sometimes the book that's given in the class may not work for you. You might like the author differently. You might like, this guy talks in this frame, this one is more example, this one's more theory. So use this book source. And if you're having trouble in any class, go get networking, go look at 3 different networking books. One of the books will work for you. Then and my role is if I like it and I'm starting to read chapters out of it online, I just go buy the book because I know I'm going to use it. But you have that access, which is awesome because you have infinite number of books. So please try it. Other questions? All right, get Perforce up and going if you haven't done it, and try it out and slowly work on this. Don't get intimidated. Also, the biggest thing here is remember, what is 5% of your grade and what is 1%? PA is 5%, basics 1%. Keep that in mind. I always have some students who spend the whole week on basics. I go, yeah, but here's this big pile of points. And they're like, but I gotta get the basics perfect. I'm like, there's this pile of points you're gonna get 0 on. So focus it that way. Focus on the big points and then the basics, will kind of come together. We have tutoring. Do not be afraid to try it. They're very good and they're all were ex-students of this class. So all the C++ stuff. All right. Thanks, everybody.
Thanks.